I'm going to teach you how to create a complete combat system in Unreal Engine 5 from scratch, so that by the end of this video, you'll know how to play an attack animation, chain attacks, attack while running or in the air. Then you'll learn how to use simple and advanced hitbox techniques to deal damage. Then I'm also going to teach you how to show an animated health bar above a damageable character, as well as how to play a directional hit reaction animation based on where the attack is coming from. After that, we are going to learn how to make each attack feel heavier by adding impact effects such as hit stop, hit shake, hit flash, camera shake, and hit VFX. And finally, we are going to see how to make a damageable character ragdoll on death when he no longer has any health points. Oh, and last but not least, our system will be completely reusable. You'll be able to add a combat system component to any character and a health system component to any damageable character, all without writing a single line of code. And before moving on with the tutorial, if you want to use the same two characters as me, you can download them for free on the Fab Marketplace. They are called Wukong and Rampage from the game Paragon, and they come with combat animations and visual effects. Okay, so to make our code modular, we are going to put all our combat logic inside what we call an actor component, which is a special type of blueprint that lets you add new functionalities to any actor you add it to. To create an actor component, I'm going to right-click somewhere in my content browser, then select Blueprint class, choose Actor Component, and name this new asset AC_combat system. I'm going to open it, and in the event graph, I'm going to create a new custom event, rename it to Trigger Attack, and then we are just going to add a print string for now. So here I'm going to press compile and save. Okay, so we'll come back to this actor component later, but for now I'm going to create an input action that will be used to trigger an attack with a left click. To do this, I'm going to right click in my content browser again, select Input, then click on Input Action. I'm going to rename this new asset to IA_attack, and then I'm going to open the default mapping context of my project called IMC default, add a new mapping to it, and bind my input action IA attack to the left mouse button. So here I'm going a bit fast on the subject of inputs, but if you want to learn more about the subject, you can check out my tutorial on how to create a third-person character available on my YouTube channel. Now that everything is set up, I'm going to add the component to my character to make it so the trigger attack function will be called whenever I left click. To do this, I'm going to open my BP Wukong, which is a simple third-person character that can move around and jump. If I launch the game here, you can see that all I can do for now is move around and jump. I'm going to close the game, and in the Components tab, I'm going to click on Add and search for Combat. I'm going to select my combat system to add it to my character, press Compile and save. Now I'm going to press Ctrl plus space on my keyboard. I'm going to drag an IA attack input action in the graph, and then I'm going to pull a trigger attack function from the started execution pin of my IA attack event. This event will be called whenever I left click. So now I'm going to compile, save, and if I launch the game, you can see that whenever I left click with my mouse, the print string I added in my component is correctly called. Okay, so now that our system is set up, I'm going to show you how to play a single attack animation whenever we left click. Like I said earlier, my character is a simple third-person character that can walk around and jump. If I open the animation blueprint ABP Wukong and go to the event graph, you'll see that it's a simple animation blueprint that tracks whether the character is in air and whether it's moving or not, so that in the anim graph, it can choose the correct animation based on the values of the in-air and accelerating booleans. Since an attack can be triggered at any time during gameplay, we want to be able to override any animation and play the attack animation instead whenever the player left clicks. To do this, I'm going to add a slot node just before the output pause here. I'm going to type slot and press compile. Here, if I select the slot node, I can change the slot's name, but for the sake of simplicity, I'm going to leave it as default slot. For those of you who don't know how slots work, you can think of them as pipes that allow us to tell Unreal Engine something like, whenever an animation goes through this pipe, I want you to ignore everything and play this animation instead. This is exactly what we want, and now I'm going to show you how to send attack animations through this pipe default slot. So here I'm going to go in my content, then combat system, and then anim attack. Here I have attack animation sequences for my character Wukong. They are all attack animations. But the problem is that I can't send them as they are through the slot I created. To be able to do this, I need to create a specific type of animation asset called animation montage by right-clicking on an animation sequence, let's say the A attack A, for example, selecting create, then create anim montage. Here I'm going to rename this new asset to am_attack A and open it. As you can see, an animation montage looks like an animation sequence, but it has a few additional features that I will show you throughout this tutorial. One of these features is that you need to define one or more slots through which it can pass by clicking on the arrow next to default slot and selecting the name of the slot you want your animation to pass through. In our case, we chose the default slot already in our animation blueprint, so we can leave it as it is. Oh, and now that I think of it, just so you know, if you change the slot name to something else, let's say for example here, melee slot, the character will stop moving and stay in a T-pose. It's a well-known Unreal Engine bug, and all you have to do is close the animation montage and reopen it to make everything work as intended. I don't know if it's the same for you, but the full animations of my attacks are split into two parts. The attack, here, and the recovery. What's cool about animation montage is that, just as the name suggests, you can play multiple animation sequences within a single montage. So here I'm going to drag the attack A recovery part of my attack animation and drag it from the asset browser into the timeline. Here, as you can see, you now have the full attack animation in a single asset. Now I'm going to create the animation montage of each of my 5 attacks, and we'll continue on with the tutorial after that. Okay, so back in our AC combat system, in the trigger attack event, I'm going to delete the print string because now I want to play an attack animation instead. To do this, first in the begin play, I'm going to get the skeletal mesh of the character the actor component is attached to. To do this, I'm going to right-click, type get owner, and select the get owner node. Then I'm going to pull a wire from this and call cast to character. I'm going to connect this to begin play. And then if the owner is a character, I'm going to pull a wire from the as character pin, select get mesh, then right click on it, promote to variable, and rename it character mesh. Then I'm going to plug the character mesh next to the cast to character, and I'm going to press compile. Then in the trigger attack event, I'm going to call a function called play montage. This function needs a skeletal mesh component as input. So I'm going to get my character mesh and plug it in the skeletal mesh component. Then I'm going to choose the AM attack B as the montage to play. I'm going to press compile and save. Now, if I launch the game and try to trigger an attack with a left click, you'll see that the animation does play, but the character seems a bit shy and doesn't play it fully. This issue is actually due to animation blending, which smooths the transition between default animation flow and the montage we want to play to make things look more natural. That's great and all, but in our case, we want the attack to feel snappy and play right away without any blending. To do this, I need to change 2 parameters in my 5 montages. And since I have multiple montages that I don't want to modify one by one, I'm going to bulk edit all of them by selecting all my montages, right-clicking, and selecting Asset Actions, then Edit Selection in Property Matrix. Here in the window that opens, I'm going to unfold the Blend option, then Blend in and Blend out, and I can define the time it takes to blend from my animation flow to my montage and back by changing the value of the 2 blend times parameter, this one and this one. In my case, I found out that 0 seconds for the blend in time and 0.2 seconds for the blend out time work well. Of course, modifying this will update these values for all animation montages. Now, if I close this and launch the game, if I try to trigger an attack, you can see that the animation plays as intended. And the character is no longer shy. So now that we know how to trigger a single attack, let's see how to chain multiple attacks together. First, I'm going to create an array that will store all the attack animations our character can play. To do this, I'm going to add a new variable by clicking here. Rename this new variable to attack anims. Then I'm going to change its type to Anim Montage. And I'm going to right-click on Anim Montage to turn it into an array of Anim Montage. I'm going to compile it, and then in the details panel, I'm going to change its category to System Parameters and press Compile. So doing this last part will make all the tweakable parameters of our system available in a single category. Now I'm going to compile the blueprint again and add my attack animations to the array. I'm going to go to the left. I'm going to add my attack animations to the array in the order they will be chained together. So here, since I have 5 different animations, I'm going to click 5 times on the plus sign. 1, 2, 3, 4, 5. And then I'm going to add my montages. I'm going to add the AM attack A, AM attack B, AM attack C, AM attack D, and AM attack E. I'm going to compile and save. Next, I'm going to create a new variable by clicking on the plus sign here. Rename it attack index current. Right-click on Anim Montage to turn it into a single variable and change its type to integer. I'm going to compile and then save. So this variable represents the index of the current attack animation we want to play when an attack is triggered. So now let's modify the trigger attack event so that we'll be able to chain attacks. So first, instead of always playing the AM attack B animation montage, I'm going to get the current attack using our index variable. Here I'm going to get the attack index current, then connect the get node to montage to play. Then we are going to check if there's still at least one attack left in the array. To do this, I'm going to get the attack index current and check if it's less than the attack anim's last index. The last index is the index of the last animation in the array. So if attack index current is smaller than last index, that means there are still at least one attack animation left to be played. So I'm going to add a branch by pressing B and clicking in the graph. I'm going to connect it like this and connect the last node to the branch. Like I said, if attack index current is smaller than attack anims, I'm going to increment the attack index current. So I'm going to select it, press Ctrl plus D to duplicate it, pull a wire from it, and type plus plus to increment its value. On the other hand, if there's no attack left in the array, I'm going to reinitialize the attack index current to 0 so that we will circle back to the first attack. Okay, so now if I launch the game and try to click multiple times, you can see that it works and that the character can chain multiple attacks together. So before moving on to the next section, let me show you a simpler way to code this last part. Here I'm going to code something and then I'm going to explain to you how it works. I'm going to get the attack index current and duplicate it by pressing Ctrl plus D. Then I'm going to duplicate this by pressing Ctrl plus D. I'm going to pull a wire from the set attack index current and search for select int. Then I'm going to connect the last node to pick A, and I'm going to get attack index current, add 1 to it, and connect this to the A input. So here, the way this code works is exactly the same as this. instead of directing the flow of execution with the branch, what I'm saying here is that I want to set attack index current to a new value based on if attack index current is less than the last index of the attack anims. In other words, if there's at least an attack left in the array, I'm going to increment the attack index current and set the attack index current to this new value. If there's no attack left in the array, then I'm going to pick B and circle back the value to 0. So now I'm going to delete this code and connect this code instead. Now, if I launch the game, you can see that nothing has changed and that the code still works as intended. Okay, so the system as it is right now has a problem. Indeed, if I launch the game and spam the left click really fast, the character can chain attacks quickly without any cooldown. What we want to do here is make it so the character can trigger the next attack only if he presses the attack button within a specific timing window in the animation called the combo input window. So here I'm going to open the AM attack E. And to be more precise, when the player triggers this attack, we want to make it so he can't launch the next attack immediately. First, he has to wait for the moment the hit occurs, here. Then, right after that, if he presses the attack button during a specific timing window, for example, between frame 20 and 40, he will trigger the next attack to make a combo. However, if he misses the combo input window, the attack animation enters what is called the recovery phase, and the player won't be able to trigger the next attack until the current one is finished. Now, what we need to do is define for each attack animation when the player can chain attacks and when he cannot. To do so, we are going to use something called animation notifies, which are notifications we can fire at specific moments in an animation to execute some code. So here in my AM attack A, to add a notify to an animation, all you have to do is right-click on the first track of the notifies section at the moment you want the notify to fire. So here I'm going to right-click there, and here you have two types of notifies available. Notify and notify state. Let's focus on the first type. A notify is a one-shot notification that triggers on the exact frame where we place it. If I choose the add notify option, you'll see that you can add different kinds of events such as playing a sound, for example, or spawning a visual effect. What we want to do here is add a montage notify, so this one, so that we can execute some code when it's fired. I'm going to click on this, then I'm going to select it, and in the details panel, I'm going to rename it to my notify. Now I'm going to save, and I'm going to show you how we can use it in our system. Okay, so back in my AC combat system, here the play montage node has a few execution output pins that fire at specific moments during the animation. For example, you can do something when the animation is finished, or when it starts blending back to the ABP animation flow. But the pin that I'm interested in is on notify begin, which fires whenever a notify is triggered. To use it, I just need to pull off a branch node and check if the notify name is equal to my notify. Then I'm going to connect this to the branch, and if the name is indeed equal to my notify, I'm just going to print something on the screen for now. So now I'm going to compile, and if I launch the game and trigger an attack, you can see that hello does appears on the screen, which means that our notify was successfully fired. Okay, so now that we know how the first type of notify works, let's have a look at the second one, the notify states. So compared to simple notifies that fire once, notify states create a timing window defined by a start and an end frame. This is exactly what we want to represent our combo input window, so let's see how it works. First, I'm going to add a new notify track by clicking on the arrow here and selecting Add Notify Track. Then I'm going to right-click on that new track somewhere in the timeline around frame 15 here. Then I'm going to select Add Notify State and choose Montage Notify Window. I want to place the notify state more precisely, so I'm going to right-click on it and change the notify frame or start frame to 15. Then I'm going to right-click again and change the Anim notify state frames, in other words, the duration, to 6 frames. Here, as you can see, we have the start at frame 15 and the end at frame 21. So finally, I'm going to select this notify state, and in the details panel, I'm going to change its name to something like maybe my notify state, so that we can catch it in our code and execute something. Okay, so back in our AC combat system, let's say that I want to track the simple notify we created earlier, as well as the notify state we just added. To do this, we can of course add a second branch here to check the second notify, and it will work. So here I'm going to do this. Then I'm going to pull a wire from the notify name and call an equal node. Then I'm going to set this new equal node to my notify state. And if the my notify state is the one that is firing, I'm going to print hello, but this time I'm going to print it in pink. So here I'm going to click on OK. And if I launch the game, you can see that it does work. That's great, but the problem is that as soon as we have many more notifies to track, the code will quickly become cluttered. Instead, we are going to use what's called a switch node, which will help us better categorize our notifies. To do this, I'm going to pull a wire from the notify name, then search for switch on name node and call it in the graph. Then in the details panel, I'm going to add 2 pin names, my notify and my notify state. Okay, so here be careful, because if you don't write them exactly as they appear in the animation, the notify won't fire correctly. So here I'm also going to uncheck the has a default pin option, because I don't want anything to be executed if the notify's name isn't one of these 2. Now I just have to delete the 2 branch nodes, connect the execution wire of the onNotify begin to the switch on name, and then I'm going to add a print string for each notify. So here I'm going to call it notify, for example, and the second print string I'm going to add notify state. Now, before checking in game if it works, what's cool about notify states is that we can catch the moment the notify timing window ends, thanks to the onNotify end execution pin of the play montage. To do this, I'm going to duplicate the switch on name node, connect it to the notify end, then I'm going to connect the notify name to the input of the switch node, and then in the details panel, I'm going to remove the my notify pin because it's not a notify state. And finally, I'm going to pull a print string from the my notify state execution pin and add end to this print string. Now, if I compile and launch the game, if I trigger an attack, you'll see that it works correctly and prints something when the notify starts and when it ends. So here I'm going to attack again, and there you go. We have 3 print string, just like what we have here in the event graph. Okay, so now that we know how notifies work, let's implement the combo logic. First, we'll start by creating our own animation notify state for placing combo input windows in our animations. To do this, I'm going to right-click in my content browser, here, select Blueprint class. Then in the new window, I'm going to unfold all classes and search for Montage. I'm going to select the Anim Notify Play Montage Notify Window class and rename it to Combo Input Window. Now I'm going to open it, and in the details panel, I'm going to change its notify name to Combo Input Window and change its color to something flashy like, let's say, yellow. Yellow. I'm going to click on OK, then press compile and save, and then I'm going to open my AM attack A montage. Here I'm going to remove the 2 notifies we added earlier, and I'm going to add our newly created combo input window notify state. To do so, I'm going to right click here, select Add Notify State, and you can see here that we have our combo input window notify state. Here, I'm going to make the timing window start just after the hit. So hit happens at frame 5. And here I'm going to make the timing window start just after the hit. So let's say at frame 10, I'm going to right click, select the notify frame and set it to 10. And then I'm going to right click it again and select Anim notify state frames, in other words, duration to 20. That way, the player will have a 20 frame timing window to trigger the next attack. If he presses the attack button when he is in the combo input window, it will chain attacks. Okay, so that's cool. Now that you know how to use notify states, I'm going to add the combo input window notify state to my 4 other attack animation montages, and then we'll go back to our combat system to implement attack cooldowns. Okay, so back in our AC combat system, we are going to make it so that when the player attacks, he won't be able to trigger the next one unless he presses the button during the combo input window. If he misses the input window, he'll have to wait for the animation to finish, which will reset the combo and set the first attack animation as the next one. So to do this, first I'm going to create a new boolean called bCanAttack. I'm going to compile and set its default value to true so that the player can trigger an attack at least once. Then when the player calls the trigger attack function, I'm going to check if the character can attack by adding a branch and connecting the can attack to the condition of the branch. So if the player can attack, then I'm going to set the can attack boolean to false to prevent another attack from triggering. Oh, and now that I think of it, here's a quick tip for you. If your branch is testing only one boolean, like it's the case here, you can do the same thing with fewer nodes by right-clicking on the can attack boolean and clicking on convert to branch. It's a small but useful quality of life improvement. So here I'm going to connect this like this and compile. Now, if I launch the game, you can see that I can attack once and then I cannot attack anymore because I haven't set can attack back to true yet. Like I said earlier, we want to let the player call the trigger attack function again only if the attack animation is finished or if the combo input window is active. To do this, first I'm going to remove the switch nodes we used earlier here and set can attack to true in the uncompleted execution pin of the play montage node. That way, whenever the animation is completed, we allow the player to attack again. Then I'm going to track the start of the combo input window notify state with the switch node. So here I'm going to pull a switch node from the notify name. I'm going to connect it to the onNotify begin. Then in the details panel, I'm going to add a pin name called combo input window. I'm going to remove the default pin, and then I'm going to set can attack to true in the switch. That way, when the notify begin and it's a combo input window, that means that the combo input window is starting, so the player can chain an attack if he wants. So after that, I'm going to duplicate this, connect it to the onNotify end, and notify name to the input of the switch, and then I'm going to uncheck can attack. I'm going to set it to false so that if the combo input window is finished, we remove the ability to chain attacks. Now, if I launch the game and click multiple times, you can see that I can chain attacks again, but there's still something we need to fix. Here, if I trigger the first attack and then wait for it to finish, making it look like I missed the combo input window, the combo won't reset, and if I trigger another attack, it will start directly with the second animation. Same here, if I click again, it would start the third animation. To prevent this from happening, we just need to set the attack index back to 0 whenever the uncompleted execution pin is fired. So here I'm going to get the attack index current, drag it to the uncompleted pin, and set it to 0 so that the combo resets if the player misses the combo input window. Oh, and before finishing this section, you can see that my combo cycles back to the first attack once the last one is finished. So here, if I chain multiple attacks, you can see that the combo never stops because as soon as we reach the end of the array, we circle back to the first animation. If you want to prevent this from happening and stop the combo at a cooldown when the combo is completed, all you have to do is make sure that the last attack animation, Montage, doesn't have a combo input window notify state. So here, if I open my AM attack E animation Montage and delete the combo input window notify state here, you'll see that if I launch the game and try to chain attacks, the combo will automatically stop when it reaches the last animation. And there you go, our combo system is officially done. Okay, so now let's see how to set things up so that whenever I trigger an attack while running, instead of the legs locking and the character sliding around like he's on a skateboard, the upper body is going to play the attack animation while the lower body is going to play the run animation. To do this, I'm going to open the animation blueprint of my character, ABP Wukong. Then in the Anim graph, I'm going to right-click, search for blend per bone, and then I'm going to add a layered blend per bone node. So this node is exactly what we need since it allows us to combine different animations on specific parts of a character's skeleton independently. Setting it up is relatively easy. First, you need to connect the base animation pose. In our case, it's the locomotion flow that I'm going to connect to the base pose input of the node. To do this, you can't simply pull a wire from the locomotion state machine because the output of a node in the Anim graph can only be connected to one node at a time. This limitation is why we use caches. So here, caches are like variables that store a pose that can be reused wherever we need. So here in my graph, I already have a loco cache to which I connected the locomotion state machine. Now, if I right-click and call loco cache, you can see that I can use the cached pose loco cache and connect it to the base pose. Oh, and just so you know, if you want to create your own cache, you can right-click, then type save cache, and select new saved cache pose. Then you're going to rename it to something like my cache, for example. Plug a pose in it, let's say this one. And then if you want to call it, you can right-click and select my cache and select the use cached pose my cache. So now I'm going to delete it, plug my locomotion back to my loco cache, and compile. Now back to my layer blend per bone node. We need to connect any other animation we want to layer on top of our base pose to the blend poses input pins that you can see right here. In my case, I want to layer the locomotion flow with the slot connected to it on top of the base locomotion flow. So to do this, I'm going to disconnect the default slot from the output pose, then store this pose in a new save cache pose. I'm going to rename it to combat cache, and then I'm going to compile and call that combat cache here and connect it to the blend poses 0. Then I'm going to connect the layered blend per bone directly in the output pose. I'm going to compile, save, and now that everything is set up, we need to tell which parts of the body are going to play the layered animation. To do this, I'm going to select the layered blend per bone node. Then in the details panel, I'm going to set the blend mode to branch filter, which is already the case here, unfold the layer setup and the index 0 parameter. Then I'm going to add a new branch filter by clicking the plus sign here. So here, a branch filter is a specific bone in the character's skeleton that determines whether the layered animation will play on that bone and its children or not. In my case, I want the animation to play on the upper part of the body. So I'm going to choose the pelvis bone so that it applies the layered animation to it and all its children. So here I'm going to type pelvis, and press enter. As for the blend depth parameter, it controls how far the blend happens in the bone hierarchy before applying the full motion of the layered animation. That means, for example, here if I set the value to 1, it will apply full blend strength to the pelvis and all its children. In my case, after some testing, I think that I'm going to set it to 4 so that the pelvis receives a 25% blend, spine 1 will receive a 50% blend, spine 2 a 75% blend, and spine 3 and all its children a full blend. Now if I launch the game, you'll see that the animation is not blending correctly, that something seems to be off. Here, if I open the skeleton of my character, Scale Wukong, you'll notice that the thigh L and thigh R, in other words, the legs of the character, are also children of the pelvis bone, which is why the blend also happened on these bones. To prevent this from happening, I'm going to go back to my ABP Wukong, select the layered blend per bone node, and add a branch filter for each thigh. I'm going to add 2 branch filter. Then here I'm going to write thigh L for the left leg and thigh R for the right leg. Then I'm going to set their blend depth value to -1. Why? Because this tells the node not to play the layered animation on those bones or their children. In other words, it won't play the layered animation on the character's legs. So here, if I launch the game and attack while running, you can see that it's better, but the upper body is oriented slightly toward the ground. This problem is due to how rotation is blended between 2 animations. Solving this is pretty simple. All you have to do is select the layered blend per bone. Then in the details panel, I'm going to check the mesh space rotation blend. I'm going to enable this parameter. This will ensure that the rotation applied by the layered animation respects the global orientation of the mesh without inheriting the parent bone's orientation. Now, if I compile and launch the game, you can see that the rotation is better, but there is still one last issue we need to solve. Here, the blend is always happening even when I'm not running, which means that the idle animation is always playing on the lower body and the attack animation is always playing on the upper body. So because of that, we lose important movement information in the animation, such as when Wukong is supposed to jump and do a 360 before landing on ground. So to prevent this from happening, I'm going to right-click in the anim graph, search for blend bool, and call and blend poses by bool. This node, you can see it as a branch in the anim graph that chooses which animation to play based on the value of a Boolean input. The way we are going to use it is simple. If the player is moving, I want to blend the 2 animations. If not, I don't want to blend the 2 animations. So first, I'm going to get my accelerating Boolean and connect it to the active value. In my case, the accelerating Boolean, which was coded here in the event graph, tells us whether the character is moving or not. So here, I'm going to connect the layered blend per bone to the true pose input pin. That way, if the character is accelerating, I'm going to blend the 2 animations. Finally, I'm going to get the combat cache, press Ctrl plus D, and connect it to the false pose input pin so that the combat animation plays on the whole body when I'm not moving. So now I'm going to connect the blend poses by bool to the output pose. I'm going to compile, and if I launch the game, there you go, our attack and run animation blending is working like a charm. Okay, so let me show you something. Here, I'm going to force my play montage node in my actor component to only play a specific attack animation by disconnecting the get node from the play montage and selecting my AM attack D animation montage. Now, if I compile and launch the game, if I attack while in place, you can see that Wukong jumps and does a 360 in the air before landing. That's great, but if I trigger this same attack while running, his upper body does a 360 while the lower body is running, which if you have a body, is something that is quite hard to achieve. So in this section, I'm going to show you how to disable the blending between the upper body and the lower body at specific times in an animation. So here I'm going to open my AM attack D animation montage. And what I want for this animation is to disable the blending at the beginning. So here, when the character triggers this animation, he starts jumping here, and then I want to re-enable the blending as soon as the character lands on the ground at around frame 12 or 13, for example. So to do this, we are going to use an animation curve that we'll have to add to any animation that has parts of it where the blend should be disabled. So here I'm going to create a curve by clicking on the arrow next to the curve track right here. Then I'm going to select add curve and create curve. I'm going to give it a name like, let's say, blend off, so that whenever its value is equal to 1, this will mean that the blend should be off. And if the value is equal to 0, that would mean that the blend should be on. Okay, so now I'm going to double click on the blend off track to open the curve in the curve editor. And like I just said, here we are going to make it so whenever the value of the curve is equal to 1, we turn the blend off and don't blend animations. And whenever it has a value of 0, we turn the blend on and therefore blend the animations. Now I'm going to set the playback to the first frame and press enter to add a new key to the curve. Then I'm going to select the key here and I'm going to set its value to 1 by setting it to 1 over there. Then I'm going to set the playback to where the player lands on the ground, somewhere around frame 12, I think. Here, I'm going to press enter to add another key, and I'm going to set its value to 0 so that the blend is enabled when the character is supposed to be running. So now that the keys are placed, I'm going to press A on my keyboard to fit the whole playback in the current view. So here we don't want the curve to smoothly go from 1 to 0. Instead, we want it to be either equal to 0 or to 1, nothing in between. To do this, I'm going to press Ctrl plus A on my keyboard so that I can select all the keys. Then I'm going to click on the linear button at the top right part of the editor. So here I have a linear button. I'm going to select this, and then I'm going to select constant. So this will apply a constant interpolation to the selected keys, which is exactly what we are looking for, because here you can see that it goes straight from 1 to 0 at frame 12. Now that the curve has been set up, I'm going to open my ABP Wukong, go to the Anim graph, right-click, search for curve, and add a get curve value node to the graph. As the name suggests, this node will return the value of the specified curve in the animation that is currently playing. So just so you know, if the curve doesn't exist in the current animation, let's say an animation where we don't want to disable the blend mid-animation, this node will simply return 0, which is exactly the value we want if we want the blend to happen. Okay, so now I'm going to set the curve name parameter to blend off. Be careful to write it exactly like how you wrote it in the curve editor. Then I'm going to pull a less or equal node from the return value, and then I'm going to create an end Boolean node to which I'll connect the accelerating bool and the less equal node. So once that's done, the only thing left to do is to connect the output of the end node to the blend poses by bool node that we added earlier in this tutorial. That way, whenever the player is running and the value of the blend off curve is equal to 0 or non-existent, the blend will happen. However, if the player is not running or if the value of the blend off curve is equal to 1, then the blend won't occur. So now if I compile and launch the game, if I trigger the attack while running, you can see that the player does jump and does a 360 in the air during the attack and starts to blend the running and the attack animation as soon as Wukong lands on the ground. Okay, so since the aim of this tutorial is to create a fully modular and reusable system, I'm going to show you how to move our animation logic to another animation blueprint that will be easy to add to other characters. To do this, I'm going to right-click in my content browser, select Animation Blueprint, then instead of selecting a specific skeleton, I'm going to click on Template to make an animation blueprint that has no target skeleton. I'm going to click Create and rename this new blueprint ABP_combat module and open it. Now back in my ABP Wukong, I'm going to select all the nodes we created. So I'm going to select all of these. Then I'm going to press Ctrl+X on my keyboard to cut them. Then go to my ABP combat module. Press Ctrl+V to paste them there. Here I'm going to connect the blend poses by rule node to the output pose. Then I'm going to right-click on the accelerating boolean and select create variable. And now if I try to compile, it's going to fail because it can't find the loco cache. Now we want to be able to send the base animation flow from the animation blueprint of my character down to this graph. To do this, we are going to right-click, search for input pose, and add an input pose node to the graph. In the details panel, I'm going to change its name to locomotion pose. Then I'm going to connect it to a new cache, new save cache pose called loco cache, so that the error will disappear when I click compile. So now that my combat animation module is finished, I'm going to show you how to code it in my character's animation blueprint. So back in my ABP Wukong, I'm going to right-click, search for linked anim graph, and add a linked anim graph node. Then in the details panel, I'm going to set the instance class to ABP combat module. And in the exposable properties here, I'm going to click bind and select expose as pin to show a pin which I can connect my accelerating boolean to. Now, all that's left to do is connect the loco cache, use cached pose loco cache to the locomotion pose, connect the accelerating boolean to the corresponding input, connect the linked anim graph node to the output pose, and there you go, you've successfully created a reusable animation module. One last thing to do, if I launch the game, the attack is not triggering anymore when I left click. This is due to the fact that animation slots in a linked anim graph are not evaluated by default. To fix this, in my ABP combat module, I'm going to click on class defaults, then enable use main instance montage evaluation data. I'm going to check this option, and this will allow us to catch the slot event whenever we play a montage. So now I'm going to press compile, and now if I launch the game, everything works correctly, and you now have a module that can be added to any other animation blueprint. So one quick thing to note before moving on to the next section, there's a small caveat in this system, which is the fact that the branch filters of the layered blend per bone cannot be exposed to be modified within the linked anim graph node. It's not that big of a deal, but note that you'll need to duplicate this module and change the branch filters for characters that don't have the same bone hierarchy. Okay, so in this section, I'm going to show you how to play a specific air attack animation while the character is jumping instead of playing a ground attack animation. So first, I'm going to go to my air attack, which is this one. Then I'm going to right-click on it and create a montage, an animation montage here that I'll rename AM_air_attack. I'm going to open this montage. Then I'm going to set its blending time to 0 so that the attack is snappy, and set its blend out time to 0.2 to smoothly blend to the animation blueprint flow. Then in my AC combat system, I'm going to create a new variable. I'm going to change its type to Anim Montage. Then I'm going to rename it to Air Attack Anim and place it in System Parameters category. Then I'm going to compile the blueprint and set this variable to my Air Attack Anim Montage. Now I'm going to create a new custom event called Air Attack that's going to play the Air Attack Anim Montage whenever it's called. So I'm going to pull a play montage from the execution pin of the Air Attack. Then I'm going to connect the character mesh to the in-skeletal mesh component and the Air Attack Anim to the montage to play input pin. So to keep things organized, I'm going to create another event called Ground Attack. Then I'm going to disconnect the logic from the trigger attack and connect it to this new event. I'm going to press compile and save. Great, so now we want to make it so that whenever the trigger attack event is called, if the player is in the air, it will play the air attack animation, and if not, it will play the ground attack animation. To do so, first we are going to store the character in a variable by right-clicking on the cast node in the begin play and selecting promote to variable. I'm going to rename this variable to character actor. Then I'm going to connect it between the cast to character and character mesh variable. I'm going to compile, and now all that's left to do is modify the trigger attack event so that it calls the air attack event when the character is in air and the ground attack event when he's on the ground. To do this, I'm going to get the character actor. I'm going to get a character movement component from it. From this character movement, I'm going to call the is falling function. And then I'm going to connect this to a branch node connected to the trigger attack event. So what I've done here is check if the character is in air or not. If he's in air, I'm going to call the air attack function. If he's not in air, I'm going to call the ground attack function. Now if I try to launch the game and attack while jumping in place, the air attack animation plays. But if I jump while running and then trigger an attack, the attack and jump animations are blended together. To fix this, in the ABP combat module, I'm going to create an in-air Boolean variable. I'm going to click on variables here, the plus sign. I'm going to rename it to be in air. Then I'm going to drag it in the event graph, call a not Boolean node, and then connect this node to the end node. That way, the animations won't blend whenever the character is in the air. So here, what I'm testing is if the character is not in air. I'm going to compile, and I'm going to my ABP Wukong. I'm going to select the ABP combat module. Then in the details panel, I'm going to click on bind and expose as pin to expose the in-air parameter. Here, I'm going to get my in-air variable from the ABP Wukong and connect it to the ABP combat module. Now, if I compile and launch the game, if I run jump, then trigger my attack, the air attack is no longer blended with the jump attack. Okay, so let's have a look at another problem that we have with the air attack animation. So here, if I jump in place and trigger the air attack just before landing on the ground, the air attack has to finish playing before playing the ground locomotion animations. Of course, this is not something that we want, so we are going to make it so that the air attack stops as soon as the character lands on the ground. To do so, in the begin play of the AC combat system, I'm going to get the character actor, pull a wire from it and call an assign landed delegate. Doing so will create a bind event to the delegate node connected to a new event by a red wire. So here, I'm going to organize this a bit. So if you don't know how delegates work in Unreal Engine, you can simply see them as notifications that are sent to whoever is subscribed to them. And the red wire you see here is just that, a subscription of the landed delegate event to the landed delegate, which is a notification that is triggered whenever the character lands after being in air. Now, just to keep things organized, I'm going to rename the landed delegate event to onCharacterLanded. I'm going to compile, And then I'm going to pull a wire from the event input of the bind event node, call create event, and select onCharacterLanded as the target function. Doing this does the exact same thing as the red wire, except that the onCharacterLanded event can be moved anywhere I want in the graph without being directly connected to the bind event node with a red wire. Okay, so just to check if everything works correctly, I'm going to add a print string to the onLanded event. Okay, print string, I'm going to compile, launch the game, and if I jump, you can see that hello is correctly printed on screen when the character lands on the ground. Great, so now I'm going to make it so that whenever the onLanded event is called, we check if the air attack anim montage is currently playing. And if it is, we should stop it. So to do this, I'm going to delete the print string node here. Then I'm going to get the character actor variable. I'm going to pull a get current montage node from it. Then I'm going to check if it's equal to the air attack animation and connect the result to a branch node. So here I'm checking if the air attack animation is currently playing when the character lands on the ground. Then if the air attack is indeed currently playing, I'm going to call stop anim montage on the character to stop it. Okay, so just so you know, if no anim montage is specified in the stop anim montage function, it will simply stop the current montage, which is exactly what we want. Okay, so now if I launch the game and try to attack just before landing on the ground, you can see that the animation successfully stops as soon as Wukong is on the ground. In this short section, I'm going to show you how to prevent the player from spamming the air attack while jumping. Maybe it's something that you want to allow in your game, but in my case, I want the player to be able to attack again only when the first one has finished playing. So first, I'm going to create a new boolean called canAirAttack. I'm going to compile and set its default value to true because I want the player to be able to air attack at least once. Then in the air attack event here, as soon as it's called, I'm going to check if the player can air attack. I'm going to convert it to branch and connect it. And then if he can air attack, I'm going to set can air attack to false before playing the animation so that the player can no longer trigger another air attack. So now if I launch the game, I can air attack only once and then I can no longer do it. So the question is, when do we re-enable the air attack? Actually, there are two places where we want to do it. First, we are going to set can attack back to true as soon as the player lands. So on character landed here, I'm going to get can air attack and set it to true at the beginning of the on character landed event. Doing this allows the character to air attack only one time per jump. That's great, but if we want to chain air attacks, we need to re-enable it as soon as the first attack is finished. So first, let's try that. If I launch the game, I can air attack once. Then when I land on ground, I can jump again and trigger another air attack. So now we are going to go to the play montage of the air attack event. And I'm going to set can air attack to true on the blend out output pin of the play montage node in the air attack event. That way, the player will be able to trigger another air attack as soon as the current one starts blending back to the jump animation. So now I'm going to compile and launch the game. And there you go. You can chain multiple attacks in air. Okay, so before moving on to the hit detection section of this tutorial, we need to fix one last issue. If you take a closer look at the play montage node, you'll see that it stops all montages whenever the node is called. It's cool because it allows you to quickly chain an air attack right after a ground attack without having to wait for the latter to finish. So here, if I launch the game, if I trigger a ground attack, then jump before it finishes playing and do an air attack, it's cool because I can chain attacks really quickly. However, the problem with that is that the logic of the uncompleted output pin of the play montage node in the ground attack function is never called. This is an issue because if I launch the game, then interrupt a ground attack with an air attack, you'll see that I won't be able to attack again when I'm back on the ground. So here, if I'm clicking, I don't attack anymore. Why? Because the can attack boolean was never set back to true because the ground attack never had the chance to finish playing. So fixing this is really easy, since all you need to do is make sure that the ground attack state is reinitialized each time the player lands back on the ground. Not only will this allow the player to attack after landing, but it will also reinitialize the ground attack combo, which is quite useful for us. So here I'm going to go in the on character landed, then I'm going to set can attack to true and attack index current to 0. So doing this makes it so whenever the character lands on the ground, he can attack again and the combo is reinitialized to the first attack. So now if I launch the game and try to interrupt the ground attack with a jump attack, with an air attack, you can see that it works as intended. Okay, so now that we know how to handle attack animations, let's tackle hit detection for when we want to deal damage with our attacks. So in this tutorial, I'm going to show you two different methods for handling hit detection, a simple one and an advanced one. First, let's focus on the simple hit detection method. So here I'm going to open my AM attack A, and if we take a closer look at that animation, it's not the entirety of it, but rather a small portion that's supposed to deal damage. To be more precise, we could say that for this animation, frame 5 is actually the impact frame. In other words, the moment the character is supposed to deal damage. So here we are going to use an animation Notify that will be fired at the impact frame so that our system can deal damage to all actors that are close enough. So first, let's create our Montage Notify. I'm going to right-click in my content browser, select Blueprint class, search for Montage, select Anim Notify, Play Montage Notify. I'm going to click on Select and rename it to Impact Frame, then open it. So here in the Details panel, I'm going to name it Impact Frame and change its color to something like cyan, for example. Then I'm going to compile, save, close it, and I'm going to add this impact frame notify at frame 5, add notify, impact frame. I'm going to add it at frame 5 of my AMA animation montage. So now I'm going to add the impact frame notify to all my attack animation montages, including the air attack one, and I'll see you in the AC combat system. Okay, so here in my combat system, I'm going to create a new event called Trigger Simple Hit. We will add hit detection logic later in this tutorial, but for now, I'm just going to connect a print string to see if it's called correctly. I'm going to press compile, and then in the ground attack event, I'm going to catch the impact frame notify to call my new event. So here I'm going to select the switch on name node on the on notify begin execution pin. I'm going to add a new pin name called impact frame, and then I'm going to connect a trigger simple hit function to the impact frame output pin. Then I'm going to do the same for the air attack event, which is over there. I'm going to add a switch on name node to the play montage. I'm going to connect it to on notify begin. Then in the details panel, I'm going to uncheck has default pin in the details panel and add a new pin name called impact frame. Then I'm going to call trigger simple hit on that impact frame execution pin. So now if I compile and launch the game, you can see that when I chain attacks, the text hello is correctly printed whenever the impact frame notify is fired. Now that our trigger simple hit event is correctly fired whenever there's an impact, we are going to spawn a hitbox that will deal damage to all actors that are in it. So to do this, I'm going to right click, search for multi-box, and add a multi-box trace for objects. If you've never seen this node before, it makes a box with a defined size, slide from a start location to an end location, and register all the actors of a specific type that got hit by this box. Later in this tutorial, we are going to deal damage to these actors, but for now, let's set up this node correctly. First, we are going to define the type of objects that we want the box to detect by pulling a wire from the object types input pin, searching for make, and selecting the make array node. Here in the make array node, I'm just going to select pawn because it's the only type of actor I want to deal damage to. Then I'm going to delete the print string and connect the trigger simple hit to the multi-box trace. Okay, so next, we need to define the size of the box and the orientation we are tracing it in. For the orientation, I want it to match the players. To do this, I can get my character actor. Then I'm going to pull a get actor rotation node from it and connect it to the orientation input pin. As for the box half size, for now we are going to set it to 50 for X, which represents the length, 100 for Y, which represents the side, and 50 for Z, which represents the height of the box. Finally, the last two things we need to set up are the start and end locations. For the start location, I'm going to make the box spawn right where the character is by pulling a get actor location node from the character actor variable. Then I'm going to connect this get actor location to the start so that the box will spawn right where the character actor is. Okay, so as for the end location, I'm going to get the actor location and add an offset in front of him to make the box slide forward. To do this, I'm going to pull a get actor forward vector from the character actor variable. Then I'm going to multiply this vector by a float set to 120. And then I'm going to add the scaled vector to the get actor location. And finally, I'm going to connect this to the end input pin of the multi-box trace node. Now, before trying this out, I'm going to set the draw debug type parameter to for duration so that I can see the box trace in game. Now I'm going to compile, launch the game, and if I chain attacks, you can see that the hitbox appears and even turn green when it hits the other character. Okay, so the system as it is really cool, but it's kind of limited because it doesn't allow us to define specific hitbox parameters for each attack. For example, maybe one of my attacks needs to have a greater range than the others, or maybe another one is supposed to deal more damage than the others. Here in this section, I'm going to show you how to set up per attack hitbox parameters. So first, I'm going to create a new structure by right-clicking in the content browser, selecting Blueprint here, and Structure. I'm going to rename this new structure to F Attack Profile, and then I'm going to open it. So, for those of you who've never used a structure before, you can think of it as a box that groups several related variables together, so you can treat them as one unit. In this case, our structure is going to contain all the parameters needed for each attack, such as range and damage amount. So now I'm going to populate my structure with all the variables I need and define default values for each of them. So here I'm going to change this first variable to damage amount, set it to float. Then I'm going to add another float called range. After that, I'm going to add two more floats. The first one is going to be called hitbox width, and the second one, hitbox height. Then I'm going to add another variable, this time of type eObject type query. Then I'm going to change its type to array so that I can have a eObject type enum array. I'm going to rename this variable to hittable object types. I'm going to compile, and then in the default values on the right side of the blueprint, I'm going to set damage amount to a default value of 10, range to 150, hitbox width to 100, hitbox height to 102, and the hittable object type, I'm going to set it to pawn. Now I'm going to compile and save. Great, so now back in the AC combat system, I'm going to add a new input to the trigger simple hit event by clicking on the plus sign here. I'm going to change the type of this input to F attack profile. Then I'm going to rename it to attack profile and click on compile. Then I'm going to right click on the input pin, select split struct pin to reveal the variables of the struct variable. After that, I'm going to replace the make array node here with the hitable object types of the input. I'm going to double click to add a reroute node here. I'm going to set it over there. Then I'm going to right click on the half size input of the box trace node, click split struct pin to expose each component separately and set each of them to 0. Then, since the box trace wants a half size, I'm going to divide the hitbox width parameter by 2, hitbox width parameter by 2, and connect it to the half size Y. Okay, now I'm also going to divide the hitbox height parameter by 2 and connect it to the half size Z. The range input here, I'm going to connect this to the multiply node over there, and there you go. You've successfully parameterized your trigger simple hit event. So here I'm going to organize the nodes, and there you go. I'm going to click on compile. So maybe you're asking yourself why I leave the half size parameter at 0. Actually, doing this makes the function trace a plane instead of a box. Why is it useful? Because it gives us better control over the range of the attack. If we changed this value to something like 50, for example, and wanted to make an attack with a range of 100, sliding the box 100 units in front of the character would indeed move it 100 units. But since it has a half length of 50, it would hit characters that are actually 150 units away. Of course, we could modify the math to take this length into account, but you'll agree with me that it's much simpler to set a length of 0 instead. So now that our hit function is ready, I'm going to delete the call to it in the air attack and ground attack events. So they are here. I'm going to delete the trigger simple hit here. I'm going to select the switch on name node and remove the impact frame input pin. Then I'm going to select the switch on name and the trigger simple hit event in the air attack and delete it. Now I'm going to open the Anim Notify blueprint impact frame that we created earlier. I'm going to double click on it. And here I'm going to click on Open Full Blueprint Editor to open the full blueprint editor. Then I'm going to click on Override here to override the function and select Received Notify. So here this function is very useful because it gets executed whenever the impact frame notify is fired in an animation. To see if it works, let's connect a print string here and launch the game to try it out. I'm going to compile, save, and launch the game. And here you can see that when I attack, hello is correctly printed on screen. That's great. So now I'm going to call trigger simple hit on our character whenever this function gets called. To do this, I'm going to pull a wire from the mesh comp input here, which represents the skeletal mesh component of the character that is playing the animation. Then I'm going to call a get owner node, which allows us to get that character. From that get owner node, I'm going to pull a get component by class and set its component class to AC combat system. As the name suggests, this node gives me access to the combat system actor component of the character. Then, just to be sure that there's a combat system on the character, I'm going to check if it's valid, is valid, and if it is, I'm going to call the trigger simple hit function on it. So here we are almost done, since the last thing we need to do is right click on the attack profile input pin of trigger simple hit and select promote to variable. Then I'm going to rename it to attack profile. I'm going to compile, and in the details panel, I'm going to enable instance editable option so that this variable can be modified directly in the animation editor. That's it. Now I'm going to compile and save. And if I open an animation montage, for example, AM attack A, then select the impact frame notify here, you'll see that I can modify the attack info directly in the details panel. So here I can modify the damage amount of this specific attack, the range, the hitbox width, hitbox height, what kind of objects it hits, and so on. So now if I launch the game and trigger an attack, you will see that the hitbox still appears correctly. So now I'm going to remove all the impact frame notifies from my attack animations. So here I'm going to remove the impact frame from this animation as well as the 4 other attack animations, because in the next section I will show you an advanced way of detecting hits. Okay, so the simple hit detection system we've just implemented is really cool, but has 2 main limitations. First, instead of tracking the weapon, it traces a box, so it's not very precise. And second, since it's a simple notify, the hit can only be fired at a specific frame, even though an attack animation usually has multiple frames that deal damage. In this section, I'm going to show you an advanced hit detection method that will not only allow us to define a timing window in the animation for dealing damage, but also define parts of the body that can deal damage, giving us a more precise and accurate way to detect hits. So first, let's create an Anim notify state for defining damage dealing timing windows in our animation. To do this, I'm going to right-click in the content browser, select Blueprint class, search for Montage window, and then I'm going to select Anim Notify, Play Montage Notify window. I'm going to click Select and rename it Active Frames. I'm going to open it. I'm going to change its color to something like pink maybe, and then I'm going to rename it to Active Frames, which is a common term in the fighting game sphere for defining frame window during which an attack can deal damage. So now I'm going to open my Anim Montage AM Attack A so that I can add this new notify state to it. So here, the goal is to define during which frame window my attack is supposed to trigger a hit. For this attack animation, I think that the active frames window should start at frame 4 here and end at frame 8, this. So here I'm going to right-click in the timeline, select Add Notify State, and then select our active frames. I'm going to right-click on it, set the start frame to 4, and set the duration, so the Anim Notify State frames, to 4, making it end at frame 8. Okay, so now I'm going to add this Notify State to all of my attack animations, including the air attack. Then we are going to continue on with the tutorial. Okay, so now that all the notifies have been added, I'm going to open my Blueprint Notify Active Frames. Then I'm going to click on Override, and this time, instead of selecting Received Notify Begin like we did earlier, I'm going to select Received Notify Tick, which, as its name suggests, is like an event tick that is called each frame during the active frames window. So before moving on to the next section, let's add a print string to this function, then compile and launch the game to see if it works. And yes, it does. Here, as you can see, the word hello is printed multiple times each time I trigger an attack. Okay, so now that our active frames are set up, let's see how to implement our advanced hit detection system. So here in the AM Attack A, unlike what we've done previously, instead of tracing a simple box during the active frames, we are first going to define parts of our character skeleton that are going to deal damage. To be more precise, for each attack animation, we are going to choose a start socket or bone, for example, the weapon R bone here on Wukong, which is placed at the center of the staff, and then an end socket or bone, for example, the weapon B, front R bone, that will represent the tip of the staff. Then once the start and end location are chosen, we are going to make a hit sphere that's going to move from the first socket to the second one to see if it hits something. Okay, so now I'm going to choose the start and end locations for Wukong's attack. Since the damaging part of the staff is always the same half, so this half is always dealing damages, as you can see here, here too, here, here, and here. I'm going to choose the weapon R bone as the start location. So this bone, placed right at the center of the staff, is going to be my start socket. As for the end location, I would like it to be at the tip of the staff, but unfortunately, no bone or socket is correctly placed. So here I have the weapon B front R that is close to the tip of the staff, but not quite at the tip of the staff. So I have to create a socket and place it where I want the end location to be. So to create this socket, I'm going to right click on weapon R, then select add socket. This socket will be created and attached to this bone. Next, I'm going to select the created socket, press F2, and rename it to weapon underscore tip. Finally, I'm going to select it. Then in the viewport, I'm going to move it along the staff so that it sits at the tip of it. So here I'm going to move the weapon tip over there. Great, so now that we've defined our locations, let's create a new structure, this time for advanced attack parameters. To do this, I'm going to right-click in the content browser, go to Blueprint, then select Structure. I'm going to rename it to F Advanced Attack Profile, and I'm going to open it. So here I'm going to add the following variables to this structure. First, I'm going to add a float called damage amount, with a default value of 10. Then I'm going to add a name variable called start socket, which will store the start location of the sphere trace. Since I know the name of my sockets, I'm going to set its default value to weapon R. That way I won't have to rewrite this in the animations. Then I'm going to add another name variable. I'm going to name it end socket, for the end location of the sphere trace, which is going to be set for me to weapon tip. Then I'm going to add another variable of type float this time. I'm going to rename it to hit sphere radius. As its name suggests, it's going to be the radius of the sphere that we are going to slide from start socket to end socket. This hit sphere radius, I'm going to set its default value to 10. Finally, I'm going to add a new variable called Hitable object types. I'm going to change its type to eObject type query, and then I'm going to change its type to array. I'm going to add a pawn to it, and there you go. I'm going to press compile and save. Oh, and now that I think of it, I'm just going to add the pawn to deal damage to pawns for my attacks, but you can add more types if needed for your games. Okay, so now I'm going to open my blueprint notify state active frames. Then I'm going to add a new variable called attack profile and set its type to F advanced attack profile. I'm going to enable the instance editable property here. Then I'm going to compile and save. Now back in my animation montage AM attack A, you can see that if I select the active frames notify state in my timeline, I can change the advanced attack parameters for this animation in the details tab. That way I can tell that this animation should deal 20 damage, the B would deal 5 damage, etc. That's great, and now that everything is ready, we can finally start implementing the advanced hit detection. Back in my AC combat system, I'm going to create a new custom event called Trigger Advanced Hit. Then I'm going to add an input of type F Advanced Attack Profile, and name it attack profile. I'm going to compile, and then I'm going to pull a wire from the execution pin, search for multi-sphere, and add a multi-sphere trace for objects node. So here, as its name suggests, instead of throwing a box in front of the character, we are going to throw a sphere along an axis that goes from the start socket to the end socket. So now implementing this event will be easier than the trigger simple hit one, because we don't have to do the math for defining the start and end locations of the trace. Why? Because they are already defined by the start and end sockets of the attack profile variable. So here I'm going to right click on the attack profile input and select split struct pin to reveal the parameters of the struct. I have the names of the start and end socket as inputs, and what I want to do is get their location in space to connect them to the start and end locations of the sphere trace. To do this, I'm going to get the character mesh and pull a get socket location node from it. Then I'm going to connect the start socket, the socket name input, and connect the return value to the start location. After that, I'm going to do the same for the end socket parameter, get socket location, connect the end socket here, the end socket name, and connect this to the end parameter. Now all that's left to do is connect the hit sphere radius to the radius parameter here. Then I'm going to connect the hittable object types to object types. And then I'm going to set the draw debug type here to for duration, so that we can see if the sphere trace is correctly triggered whenever we attack. Now I'm going to open my active frames notify blueprint, and in the received notify tick function, I'm going to delete the print string and make a call to our new function instead. To do this, just like before, I'm going to pull a get owner node from the mesh comp, get owner, to get the character. Then I'm going to call get component by class and set it to AC combat system. That way we'll get our system, and then I'm going to connect this to a isValid node to check if it does exist on my character. And finally, I'm going to pull a trigger advanced, advend, it will name it to advanced. So trigger advanced hit and connect this here, this here, and then I'm going to connect the attack profile variable to the function's input parameter. So now I'm going to compile, and if I launch the game and chain attacks, you can see that the sphere traces appear, which means that our system is working correctly. Now that our hit detection system is done, I wanted to give you some quick notes before moving on to the next part of the tutorial. So first note, here I only add one active frame notify per attack, but actually you can add as many as you want to each attack. It can be useful, for example, if the character deals damage with his left and right hand, or if you want something like the tip of the sword dealing more damage than the bottom part of it, just like in Smash Bros, for example. Second note, advanced hit detection also works if you just want to spawn the sphere only on the hand because you are playing a boxer. So here I've shown you that you are going to throw a sphere that goes from a start location to the end location, but if you have a character that just have a punch, you can set the start and end location to the same bone so that the sphere will stay there during the impact frames. And last note, each of the two hit detection methods I presented here has its pros and cons. If you have a perfectly animated attack that is realistic, I would suggest using the advanced hit detection. If the animation, however, does not really represent the area of damage the attack is supposed to have, then maybe you should use the simple hit detection system. No hit detection system is better than the other. So all that to say, it's up to you to choose the method that best fits your specific needs, and you can check whatever works the best for your game. Okay, so now that our hit detection system is working correctly, I'm going to show you how to deal damage to all actors that were detected by our box and sphere traces. So here in my AC combat system, the box trace and sphere trace nodes we used in our simple and advanced hit events each return whether the trace hit something, and if so, they give us all the hits that occur during the trace. Now what we are going to do is process this result and deal damage to all actors that were hit by the shape traces. To do this, I'm going to create a new function by clicking on the plus sign over there. I'm going to rename it to apply damage to hit actors. I'm going to press compile, and then I'm going to add the following inputs to it. So I'm going to add the first float input called amount that represents the amount of damage to deal to hit actors. Then I'm going to add another input of type Boolean this time. I'm going to rename it to hit, and this input tells us if the shape trace hits something or not. And finally, I'm going to add a last input called hits. I'm going to set its type to hit result. And then I'm going to select its type and change it to array. This last input is going to be connected directly to the shape trace node to get all the hits that occur during the trace. So now I'm going to press compile, and before implementing the logic of this function, I'm going to call it in the simple and advanced hit functions like this. So compile, event graph, and in the first trigger simple hit, I'm going to call apply damage to hit actors. I'm going to connect the out hits to hits, the hit to return value, and the amount of damage to the attack profile damage amount. And then I'm going to do the same in the trigger advanced hit. I'm going to call apply damage to hit actors. I'm going to connect it here, connect the return value to hit, the out hits to hits, and then I'm going to connect the amount to the advanced profile damage amount. Now that everything is ready, let's implement the damage function. I'm going to double click on it. And here, first, I'm going to pull a branch from the hit boolean input. This will allow us to check if anything was hit during the trace. Then I will pull a wire from the hits array and create a for each loop so that I can execute some logic on each actor that was hit. So here the loop body will be called for each actor that was hit by the shape trace. Next, I'm going to pull a break hit result from the array element, break hit result, to reveal the parameters of the hit result. After that, from the hit actor parameter, I'm going to call the apply damage function, which is a native function of Unreal Engine used to deal damage to actors. So I'm going to connect it to the loop body so that we are going to apply damage to all actors that were hit by the trace. And finally, I'm going to connect the character actor variable to character actor variable. I'm going to connect it to the damage causer input so that the actor knows who dealt damage to it. I'm also going to get the amount parameter here, right click, get amount to get the amount parameter of the function. These two are exactly the same. And then I'm going to connect the amount to the base damage so that we can apply a defined amount of damage. So now I'm going to press compile and save. Okay, so the apply damage that we used in our function is a built-in function of the engine for dealing damage to actors that are set up to receive them. So in this section, I'm going to show you how to set up an actor to take damage and implement the logic that will run every time it receives damage. So here I'm going to open my BP rampage, and here I have a simple character based on rampage, a character from the game Paragon. It has no logic implemented in his graph, and a simple animation blueprint called ABP Rampage, which plays a looping idle animation, is assigned to it. So to set up damage reception for this character, first we are going to check if the character can receive damage by clicking on class defaults. Then I'm going to search in the details panel for damage and check if can be damaged is enabled. In my case, it's already enabled, so we are good to go. Okay, so now that we know Rampage can take damage, all we need to do is right-click somewhere in the event graph, search for any damage, and add an event any damage to the graph. So now I'm just going to add a print string to the event to see if it works correctly. Okay, so now if I launch the game and try to attack Rampage, you can see that the text hello does appear on screen, but the problem is that it's printed multiple times per attack because a hit is detected by multiple sphere traces. Why is this a problem, you might ask? It's a problem because it means that, for example, if an attack is supposed to deal 20 damage points and hit is detected 5 times during a single attack, then Rampage will receive 100 damage points instead of 20 for that attack. To prevent this from happening, we are going to add a cooldown that whenever Rampage receives damage, it will prevent it from receiving more damage for a specific amount of time. To do this, I'm going to set can be damaged to false, set can be damaged to false at the beginning of the any damage. Then I'm going to add a small delay of maybe something like 0.2. I'm going to leave it as it is. And then I'm going to set can be damaged back to true so that when the character receives damage, he can't receive any more damage for a set amount of time. So now if I compile and launch the game and try to chain attacks on Rampage, we can see that it works because this time hello is printed only once per attack. Okay, that's great, but to make it look more realistic, I'm going to make Rampage play a hit reaction animation whenever it receives damage from Wukong. To do this, I'm going to go to my Anim Hit folder, and here I have 4 different hit reaction animations based on where the attack is coming from. To be able to trigger these animations when Rampage receives damage, I'm going to select them, right-click, and create an Anim montage for each of them. Then I'm going to select all these Anim montage, right-click, Asset Actions, and select Edit Selection in Property Matrix to batch edit them. Next, I'm going to unfold blend option and set blend in time to 0 and blend out time to 0.2 so that the hit plays right away while the ABP animation flows blends back during 0.2 seconds by the end of the animation montage. Now that the montages are correctly set up, I'm going to save it. And to be able to play them on top of the animation blueprint animation flow, I'm going to open ABP Rampage, and in the anim graph, just like what we did with Wukong, I'm going to add an animation slot set to default slot between the idle animation and the output pause. I'm going to compile, and now everything is set up correctly. So back in my BP Rampage, I'm going to replace the print string of the event any damage with a play montage. I'm going to get the mesh of the character and plug it in skeletal mesh component, and I'm going to play the hit react front montage for now. So here I'm going to delete the print string, I'm going to set the play montage here, reorganize everything a bit, and now I'm going to compile and save. Okay, so now instead of using the delay for the cooldown, I'm going to delete it and connect the set can be damaged on the uncompleted pin of the play montage so that Rampage won't be able to receive damage until the animation is done playing. So if I compile, save, and launch the game, you can see that if I try to chain attacks on Rampage, it works correctly because he takes damage only when the hit reaction animation is finished. Okay, so let me show you something. Here I'm going to set the play rate of the play montage to 0.5 so that the hit reaction animation plays 2 times slower. Now, if I compile and launch the game, and then if I quickly chain multiple attacks on page, the hit reaction animation is so slow that only a few of the 5 attacks land. This is a problem because when the player makes a combo by chaining attacks, he expects each attack to deal damage, which is not the case here. In this section, I'm going to show you how to code a logic that will make it so each attack lands 1 time and 1 time only. To achieve this, we are going to create an array that will contain all the actors that got hit by an attack. Then once a new actor is detected by the hit trace, we are going to check if this actor is not already stored in the array. If it is, we do nothing. If it's not, then we deal damage to it and add it to the array. So here, back in my AC combat system, I'm going to create a new variable, rename it to hit actors, change its type to actor, and right-click on actor to make it an array of actors. I'm going to compile and save, and this is going to hold all the actors that were hit by the current attack. So now each time a new attack is triggered, we are going to empty the array of actors so that no actors have been marked as hit for this attack yet. To do this in my ground attack event, just after the bull can attack has been set to false, I'm going to empty the array by calling clear on it. Okay, so here in the ground attack function, I'm going to clear the hit actors array right when it triggers a new attack. I'm going to do the same in the air attack and call clear on the array just after the can air attack has been set to false. Why? Because since we are triggering a new attack, we want to make it so no actor has been marked as hit. So now in the apply damage to hit actors function, first I'm going to add each hit actor to the array. So to do this, I'm going to right-click on the hit actor pin of the break hit result, then select promote to local variable to create a variable that is available only during the execution of this function. I'm going to rename it to hit actor, and I'm going to connect it between the for loop and apply damage. I'm also going to connect this hit actor here to damaged actor, which is the same. And then just after the damage has been dealt, I'm going to call add on the array of hit actors. So I'm going to get the hit actors. I'm going to add the hit actor to the array. So each time we damage a new actor, we are going to add it to the array to mark it as damaged. Finally, before applying damage to the actor, I'm going to check if the actor isn't already in the hit actors array. To do this, I'm going to add a branch between the set hit actor and apply damage node. I'm going to get the hit actor local variable and set it to damaged actor. Then I'm going to add a branch here. And with this branch, I'm going to check if the hit actor has already been damaged. So to do this, I'm going to get the hit actors array. I'm going to call contains item on it and connect the hit actor to the input. Doing this will allow us to check if the hit actor is already in the hit actors array. Then I'm going to pull off a not Boolean node from this, and I'm going to connect this to the branch. That way, if the actor is already in the array, it won't receive any damage. Okay, so before trying it out, I'm going to compile, go to BP rampage, and then I'm going to remove the to can be damaged node from the event any damage. I'm going to leave the play rate at 0.5 and launch the game. And here you can see that if I chain attacks on rampage, each attack deals damage at least 1 time, even if Rampage hasn't finished playing his hit reaction animation yet. So now I'm going to set the play rate back to 1, and we can move on to the next part of this tutorial. Okay, so here I have 4 different hit reaction animations: back, front, left, and right. And in this section, I'm going to show you how to detect where an attack is coming from so that I can play the corresponding hit animation. The logic I'm going to code here is simple, but well adapted for what we want to do. The way it works is easy to understand, since all we're going to do is compare the exact location of a hit to the location of front page and play the correct animation. So now I'm going to go to my AC combat system. Then in the apply damage to hit actors function, I'm going to set the focus on apply damage. So here, apply damage is useful for dealing simple damage, but we don't have a way to tell it where the damage is happening. To do this, to fix this issue, I'm going to replace the apply damage function with another one called apply point damage. I'm going to connect this here. Damaged actor, I'm going to put it there, amount there, and character actor is going to be the damage causer. I can delete the damage, any damage, apply damage, and here we can see that apply point damage takes a few more parameters as input, such as hit from direction, which represents the direction pointing from the hit location to the damage causer, and hit info, which contains the hit result. So we're going to use the latter, which will then be used in Rampage to choose which directional hit reaction animation to play. So to do this, I'm going to right-click on the array element pin of the for loop and select promote to local variable to store the hit result. I'm going to rename it to hit result. And then I'm going to connect this to the loop body and to the hit actor and add it as an input for the apply point damage. Now, if I try to compile, it will fail because apply point damage expects a value in the hit from direction input. In our case, we don't really need it because we are going to recalculate everything in the hit actor. So I'm just going to right-click on the hit from direction and select split struct pin to set its values to 0. Now, if I try to recompile, it does succeed. Okay, so back in BP Rampage, even though any damage will still be triggered on receiving damage, I'm going to replace it with an event point damage so that it can get the hit result value and perform some calculations on it. So now I'm going to compile. And now to choose the correct animation to play on hit, we are going to perform some calculations on the hit location parameter. The hit location is this parameter, which holds the exact location where the hit happened. To do so, I'm going to create a new function by clicking here. I'm going to rename it hit location to direction. That will, as its name suggests, get the location of the hit and output a direction telling where the hit came from relative to the character. Then I'm going to enable the pure parameter here of the function. I'm going to add an input of type vector, rename it to location, and an output of type e-direction, and rename it to direction. So just so you know, an e-direction variable is an enum that can, an enumerator that can be equal to any of these values: front, back, left, right, up, and down. So now I'm going to implement the logic of this function. First, I'm going to calculate the direction from the actor to the hit location by adding a getUnit direction node, connecting the location parameter to the toInput and the getActorLocation node to the fromInput. So this is going to give me the vector that points from the actor, so Rampage, to the hit location. Okay? Then I'm going to compare this direction to the one pointing in front of the character. To do this, I'm going to call a dot product on getUnitDirection. Then I'm going to connect a get actor forward vector to it and call an A cos degrees on the dot node. So here, this logic allows us to get the angle between the actor to hit vector and the one pointing in front of the character. What we can do with this angle is add a less equal node here, less equal node, set it to 45 and connect it to a branch. So now I'm going to connect the branch to the first node here, and there you go. Here what I've done is, if this condition is true, it means that the actor to hit vector, so the vector that points from ramp page to the hit location, is more or less pointing forward, so we can assume that the hit is coming from the front and therefore add a return node set to front. So now we can replicate this same logic for all other directions. So here I'm going to select everything except the get unit direction node, press Ctrl plus D to duplicate it. Then I'm going to connect the false pin of the first branch to the second one and connect the get unit direction to the dot product here. So we've already tested the forward direction, so I'm going to add a negate vector between the second get actor forward vector and the second dot product. So doing this will allow me to get the vector pointing at the back of the character. And finally, I'm going to change the direction of the return node to back. And there you go. Now we've tested if damage is coming from the back. Okay, so now that we've tackled the front and back directions, checking for the left and right ones is going to be easier. So to do this, we are not going to duplicate everything again. Instead, we are going to get a dot product from the get unit direction. A dot product. And then I'm going to call a get actor right vector, connect it here. Then I'm going to add a greater than 0 node from the dot product and add a branch from that greater than node. I'm going to connect this branch to the second one. And since we've already checked for front and back, all we want to know is whether the actor to hit vector is more or less pointing right. And just so you know, checking if the dot product is positive does exactly that. So if the branch returns true, that means the hit comes from the right, and we can add a return node set to right. If this branch is false, if this branch returns false, there's only one option left. The hit is coming from the left part of the character. So now I'm going to compile. And now that the function is implemented, we are going to use it in the event point damage. So here, I'm going back to the event graph, and I'm going to get a hit location to direction from the hit location parameter of the event. And then I'm going to pull a wire from the montage to play input pin, call a select node, and connect the hit location to direction to the index input of the select node. Doing this allows us to select a montage to play based on the value of the direction output. So here, what I will do is select the correct montage. So for left, I'm going to call A hit react left. For right, I'm going to call A hit react montage, right? Front, hit react front, and back, hit react back. So since I don't have up and down hit montages, I won't put anything in the corresponding inputs, but it's not really a problem because we don't take that into account in our hit location to direction function. So now if I compile and launch the game, if I try to attack Rampage from various angles, now from the left, now from the back, now from the right, you can see that it plays different hit reaction animations based on where the hit is coming from. Okay, so in this section, I'm going to show you how to relocate this damage logic into an actor component to make it easily reusable on other characters. So to do this, I'm going to right-click in the content browser. Then I'm going to select Blueprint class, then actor component to create a new actor component that I'm going to rename to AC_health system, because it will handle everything related to taking damage, including health and much more. So now I'm going to open it. And in the begin play, I'm going to add a get owner node, cast this owner to character. After that, I'm going to promote this to a variable called character actor. And there you go, we now have a variable that stores a reference to the character this component is added to. So now I'm going to import the logic that we implemented earlier. To do so, I'm going to go in my BP ramp page. I'm going to select the hit location to direction. I'm going to press Ctrl+C on my keyboard to copy it. Then I'm going to go to my AC Health system, click on Functions and press Ctrl+V to pass the function. So here, if I try to compile, it will fail because get actor nodes such as get actor location, get actor forward vector, get actor right vector, these nodes need to be called on an actor. So to fix this, I'm going to get my character actor variable and connect it to all the get actor nodes. So I'm going to connect this to all get actor nodes. And now if I try to compile, you can see that it succeeds. Great, so now back in my BP ramp page, I'm going to select the event point damage and its code, press Ctrl+X to cut it, go to the event graph of the AC Health system, and then I'm going to press Ctrl+V to paste it here. So here we have two issues. First, the mesh variable is grayed out because the actor component doesn't have a mesh parameter. To fix this, I'm going to delete this variable. Then I'm going to get my character actor variable and get mesh from this variable. Then connect this to the skeletal mesh component input of the play montage. The second problem that we have is that the event point damage was replaced by a custom event because an actor component doesn't have an event point damage. To fix this, just like we did earlier in this tutorial, I'm going to subscribe this event to a dispatcher that's fired whenever event point damage is called on the character. So to do this here in the begin play, I'm going to pull a wire from the set character actor node and call assign on take point damage on it. So here I'm going to connect this the character actor. Then I'm going to delete the custom event, connect the play montage to the new event, and connect the hit location to the hit location to direction node over there. Okay, so now before checking if everything works correctly, instead of using a select node right here, we are going to create a map variable that the user of the system will be able to populate with the hit reaction animations of the character. To do this, I'm going to create a new variable called hit react animations. I'm going to change its type to e-direction. And then in the details panel, I'm going to click the button next to the variable type here. I'm going to select map and change the value type to Anim Montage. Anim Montage. Doing this will allow us to choose a hit reaction animation for each possible value of e direction. So now I'm going to compile and change its category to system parameters and click again on compile. Okay, so in the on-take point damage event, I'm going to delete the select node. Then I'm going to get the hit react animations variable, call a find on it, connect the hit location to direction function to it, and connect the find node to the montage to play input of the play montage. So here the find node will act like a select and output the animation corresponding to the hit direction value it's given as input. Now a quick thing before testing it out, I'm going to remove the red wire between the bind event and the on-take damage event, and I'm going to replace it with a create event set to on-take point damage event. That way we won't have any dangling red wire. I'm going to compile, and now that the base logic of our component is finished, we are going to test it. In my BP rampage, first, I'm going to delete the hit location to direction function because we don't need it anymore. Then, in the Components tab, I'm going to click on Add, search for Health, and add our AC Health system to it. I'm going to click on Compile, and then in the Details panel, I'm going to populate the Hit React Animations parameter. I'm going to click on the plus sign 4 times. I'm going to get the left hit react animation and set it to a hit react left. The right, I'm going to set it to a hit react right. Then I'm going to get the front, a hit react front, and the back, a hit react back. Okay, that's it. So now I'm going to compile, and if I launch the game, you can see that everything still works like a charm because Rampage is reacting to the attack and has a directional hit reaction based on where the attack is coming from. So it's really cool because our character doesn't have any logic implemented, and yet the damage taking system is fully modular and reusable. All we have to do is add the health system component to any character and it will react to attacks. Okay, so in this section, we are going to add the logic for handling health to our AC health system. So first, I'm going to create a new variable called max health points. I'm going to change its type to float. I'm going to remove the map option here. I'm going to place it in the system parameters category. I'm going to click compile and set its default value to 100 so that the character can have a maximum of 100 health points. Okay, so then I'm going to create another float called current health points, which represents the points the character currently has. I'm also going to set its value to max health points in the begin play. So here I'm going to set in the begin play current health points to max health points. So doing this, each time the game starts, current health points will always start with the same value as health point max. Okay, so now I'm going to create a new custom event called process damage, which will be used, you guessed it, to apply damage to the character. Then I'm going to add a new input to this event, rename it damage amount, and change its type to float. I'm going to compile, and now I'm going to start implementing it. So here I'm going to get the current health points. I'm going to pull off a subtract node from it and connect damage amount to the bottom pin of the subtract node. That way we update current health points by subtracting the damage from it. Then I'm going to get a max float node from the subtract node, and then add a set current health point node here and connect it to the max node. So here what I'm doing is that whenever I receive damage, I'm going to remove the damage amount from the health points and the max node will allow us to make it so the value of current health points never goes below 0. So finally, I'm going to add a print string node here and connect the current health points so that we can see the new value of the health points each time it updates. Now that we've got the base version of our function, let's call it at the end of the onTake point damage. So here I'm going to onTake point damage event, and then I'm going to call process damage. I'm going to connect the damage parameter of the point damage to the damage amount input of the process damage. Okay. Now, if I launch the game and deal damage to Rampage, you can see that it works. On the top left corner, you can see the new health points of Rampage updating each time I land a hit. And when they reach 0, they never go below 0. Okay, so now when the health points reach 0, we are going to stop the hit reaction montage and prevent Rampage from receiving more damage to simulate Rampage's death. So here in the process damage, I'm going to add a branch to check if current health points is less or equal than 0. Okay, so now we are checking, does the current health points equal 0? Then if they are equal to 0, I'm going to get the character actor, call stop anim montage on it so that it won't play any hit reaction. And then I'm going to set can be damaged to false so that it won't be affected by any apply point damage function. Now, if I compile and I launch the game, if I chain attacks on Rampage, it keeps losing health points, and as soon as they reach 0, it stops playing the hit animation and doesn't receive any damage anymore. Okay, so now let's add some realism to the death of Rampage so that it becomes a ragdoll and falls down as soon as its health points reach 0. So to do this, first you need to check if your character's skeletal mesh has a physics asset assigned to it. To do this, I'm going to open my BP Rampage and then I'm going to open the skeletal mesh. Here in the asset details, I'm going to search for physics asset, and you will see in my case that I don't have any physics asset assigned to my character. So since I don't have a physics asset, I'm going to create a new one for Rampage. To do that, I'm going to right click on my skeletal mesh, select create, then physics asset, and choose create and assign. I'm going to click on create asset, and then it will be automatically opened. So here I'm going to click on the hamburger button in the top right corner and click simulate to see how the character will fall to the ground when he dies. Since the physics asset was generated automatically, the result isn't that great, but it's good enough for what I need to demonstrate. So making a decent physics asset takes a lot of time, but if you want the best result possible, you can check out the many good tutorials available online. Great, so now that our physics asset is created, I'm going to go to the process damage event of the AC health system to continue the implementation. So here, after we stopped Anim montage and disabled damage, I'm going to pull a wire from the character actor variable and call getMesh. I'm going to pull a wire from this getMesh node and call setSimulatePhysics on it. I'm going to connect it to the can be damaged variable, and I'm going to enable the simulation. Doing this will start the physics simulation and make Rampage fall to the ground, just like when we clicked simulate in the physics asset editor. So now I'm going to compile, and if I launch the game and kill Rampage, you can see that he falls through the roof, which is obviously something that we don't want. So here the fix for this is really simple. I'm going to open BP Rampage, then I'm going to select the mesh, and in the collision category of the details panel, I'm going to set the collision presets to custom and change the collision enabled parameter to collision enabled query and physics instead of query only. That way, physics bodies such as our physics asset will have their collision enabled. So now if I launch the game and kill Rampage, you can see that the ragdoll works and he falls to the ground without going through it. Okay, so that's great, but since we want our system to work simply by adding it to a character, we are going to enable physics collision directly in code without having to open the character blueprint to modify its collision settings. To do this, first I'm going to set the collision enabled parameter back to query only, then set the collision presets back to character mesh. I'm going to compile, and then back in the AC health system, I'm going to go to the process damage event, and then I'm going to get a set collision enabled from the characters mesh. I'm going to connect it here and here, and I'm going, of course, to set this new type of collision to collision enabled query and physics. Okay, so now as soon as the character dies, we are going to enable physics collision, then make the character ragdoll and fall to the ground. So now if I launch the game and kill Rampage again, so here to go faster, I'm going to set current health points directly to 0 to one-shot Rampage. So here if I launch the game and kill Rampage, he does fall to the ground, but if I try to move through him, I'm blocked because the capsule collision is still colliding with the player. So to fix this, I'm going to get the capsule component of my character actor, and then I'm going to get a set collision response to channel node from it. This node, I'm going to set the channel parameter to pawn and the new response to ignore, so that when the character dies, I'm going to get the capsule and tell it, okay, every pawn in the world, you are going to ignore them. So here, if I launch the game and kill Rampage, you can see that now I'm no longer blocked by his capsule. So now another thing that I'm going to do is make the character disappear a few seconds after its death. To do this, I'm going to add a set timer by event. I'm going to set its time parameter to something like 4 maybe, so that the mesh is destroyed 4 seconds after character's death. I'm going to pull a wire from the events parameter and add a custom event. I'm going to rename this custom event to destroy. And then I'm going to get my character actor and call destroy actor on it. Then I'm going to connect this destroy actor to the destroy event. And now you might have guessed it, but the set timer node works like a delay. So here, this delay is set to 4 seconds. That calls the destroy event 4 seconds after the character is dead. So now if I compile, launch the game, and kill Rampage for the last time, maybe, he falls to the ground, I can walk through him without getting blocked, and after a few seconds, he disappears. Okay, so now let's create a small health bar that will constantly appear above the character the health system is added to. So first I'm going to create a material for our health bar by right-clicking in the content browser, selecting material, then renaming it to m_health bar_UI. Then I'm going to open it, and in the details panel, I'm going to set its material domain to user interface and its blend mode to translucent. Doing this will make the material usable as a UI element, which is exactly what we want. Okay, so here we are going to create a health bar that uses 3 colors: gray for the background, red to show the damage amount when the character receives an attack, and green for the health points. So first I'm going to add a texture coordinate node. Right click, texture coordinate. I'm going to unfold this. I'm going to pull off a component mask from it. I'm going to unfold it and uncheck the green channel. So now if I click on the small play button on the mask node to preview the result, you can see that it creates a horizontal gradient that goes from black to white. So in material terms, this means I created a gradient that goes from 0 on the left to 1 on the right. So here I'm going to click on the small eye and show border so that we can constantly see the borders of the material. Okay, so next I'm going to pull off a step node from the component mask. Then I'm going to right click on the X input and promote it to a parameter that I'm going to rename fill level. I'm going to set its default value to 0.5. And here the step node makes values of the horizontal gradient that are greater than fill level black and values that are smaller white. So here I'm going to press play on a step value, and you can see that everything that is below 0.5 is going to be white, and everything that is above 0.5 is going to be white. So in other words, we've just created a small black and white gauge whose fill level can be controlled by choosing a value between 0 when it's empty and 1 when it's full. So now I'm going to press V on my keyboard and left click twice to spawn two color parameters. I'm going to rename the first one empty color and change its color to something like gray. Then I'm going to rename the second color to fill color, and I'm going to change its color to green. And here, of course, if you want, you can change this color to fit your own needs, but here I'm going to choose standard colors. So here I'm going to connect the RGBA output of the empty color to a LERP, linear interpolate, okay? So here I'm going to connect the RGBA output of the empty color to the A input of the LERP and the RGBA output of the fill color to the B input of the LERP. And finally, I'm going to connect the step node to the alpha. So here, if I stop previewing the step node and connect the LERP node to the final color, you can see that the gauge is now green and gray. Why? Because the LERP node outputs the color in A when alpha equals 0 and the color in B when alpha equals 1. So here I'm going to pull a component mask. I'm going to enable only alpha and I'm going to connect it to opacity. Okay, so now that we have it, we are going to add the red part of the gauge that will highlight the damage amount received by the character. To do this, I'm going to create a logic similar to what we've just done. So first, I'm going to select the step and fill level nodes. Then I'm going to duplicate them by pressing Ctrl+D. I'm going to connect the component mask to Y, and then I'm going to rename the copy of fill level to hit level. I'm going to set its value to 0.6. Next, I'm going to add another LERP node by pressing L on my keyboard and clicking. I'm going to connect it to the A input of the first LERP node, and then I'm going to get the empty color and connect it to the A input of the second LERP node. Okay, so now I'm going to connect the new step node to the alpha, and finally I'm going to hold V on my keyboard, click in the graph and rename it, this new color, to hit color. I'm going to open this hit color and change its color to something like a red color. I'm going to press OK and connect the RGBA in the B parameter. So now you can see here that we have a 3-color gauge that we are going to use for our system's health bar. So now I'm going to save it and we are going to create a new widget that will use this material. Okay, so now I'm going to right-click in my content browser, select User Interface, then Widget Blueprint. Next, I'm going to click User Widget, rename this new widget to WBP_health bar and open it. Here I'm going to drag an image from the palette to the designer. I'm going to rename it to health bar. I'm going to enable the is variable parameter so I can access this image in code. I'm going to expand the brush section in the details panel and set the image parameter to M health bar UI, the material that we've just created. So now, before implementing the logic of this health bar, I'm going to show you how to spawn it above the head of the damageable character. So here I'm going to go to my BP rampage, and to add the health bar above the character, I'm going to add a widget component in the components tab. So here I'm going to click on add, search for widget, and select widget. Then in the details panel, I'm going to set the space parameter. Where is it? Okay, so here the space parameter, I'm going to set it to screen so that it always faces the camera. Then I'm going to set the widget class to WBP health bar, and I'm going to set the draw size to 80 by 10. Finally, I'm going to move the widget component above rampage. I'm going to press compile, and if I launch the game, you can see that the health bar has been correctly added to our character. Okay, so that's great, but to stay consistent with what we've done so far, I'm going to delete the widget component and show you how to add it directly from our health system. So I'm going to press compile, and now back in my AC health system, I'm going to create a new event called spawn health bar. Then I'm going to compile and add a create widget node. I'm going to set it to WBP health bar. I'm going to promote this to a variable. I'm going to rename it to health bar. And then I'm going to compile. Next, I'm going to call add component by class. Add component by class. I'm going to call it on the character actor, so that I'm going to add a component to the character actor, in other words, rampage. Then I'm going to set its class to widget component. And after that, I'm going to split the relative transform pin and then split the relative transform location again. So after that, I'm going to get the capsule component of the character actor. I'm going to get half height, get the capsule half height. I'm going to pull off and add node from it. Then I'm going to set the value to 30. I'm going to compile, then promote this value to a new variable called health bar z offset. I'm going to compile and move this variable to system parameters. Now I'm going to collect the add node to the relative transform location, the input of the add component node. So here what I've done is that I've got the height of the capsule component of the character, and then I added a small offset of 30 so that it can be placed right above our character. So now I'm going to compile, and now on the return value of the add widget component, I'm going to call set widget space and set it to screen. This is what we've done earlier directly in the character. Then I'm going to call a set widget node. I'm going to set it to the health bar. Okay. And finally, I'm going to call a set draw size that I'm going to set to, let's say 80 by 10, which is the size of the health bar above the character. I'm going to compile, then I'm going to right click on this and promote to variable. I'm going to rename it health bar size. I'm going to compile the blueprints and set the health bar size in the system parameters category. So now all that's left to do is call the spawn health bar function in begin play. So I'm going to go to the begin play node. Here I'm going to call spawn health bar. And there you go. Now, if I compile and launch the game, you can see that our character, Rampage, has a health bar above his head. Okay, so now that we have a health bar in this section, I'm going to show you how to update the level of this health bar. So now I'm going to open my WBP health bar. I'm going to go to the event graph. And here in the event construct, which is like a begin play for widgets, I'm going to get the health bar and call get dynamic material. I'm going to connect this to the event construct, and then I'm going to promote the return value to a new variable called material. Okay, so now that I have access to the material of the health bar, I'm going to create two events for updating the fill level and the hit level parameters of the material. That way, we'll be able to control the green part as well as the red part of the health bar. So here I'm going to right click, custom event. I'm going to rename it to set fill level. I'm going to add an input to it of type float. I'm going to rename this float to level. Then I'm going to compile. I'm going to right click level and promote to variable. I'm going to rename it fill level. Then I'm going to get the material parameter and call set scalar parameter value to change the value of a scalar in the material. So now I'm going to connect the fill level to the value, and the parameter name that we are going to modify is fill level. So be careful, you need to write it exactly like this, so without any space. So here I'm going to write fill level, and then I'm going to select this, press Ctrl plus D to duplicate. I'm going to rename this event to set hit level. I'm going to delete this, right click, promote to variable. I'm going to rename this to hit level. I'm going to connect it back between the set parameter value and the set hit level. I'm going to connect this like this. And I'm going to change the hit level parameter. Okay, so now let's try these events. I'm going to compile and save. And then I'm going to call these two events in the event construct and set their level to 1. So here I'm going to call set fill level. I'm going to set it to 1. And then I'm going to call set hit level. And then I'm going to set it to 1 as well. So now if I launch the game, you can see that it works since the health bar of Rampage is now completely full. Okay, so now that it works correctly, in the process damage event of our health systems, I can finally delete our good old print string and replace it with an update to the fill level. So here I'm going to call the health bar. I'm going to call set fill level on it. And the value that I'm going to give it is current health points divided by max health points. So when I divide the current health points by max health points, what I'm doing exactly is normalizing the current health points to a value between 0 and 1 so that we can effectively give it to the material. So here I'm going to connect this to the set fill level. And before trying it out, I want the health bar to disappear when the character dies. So to do this at the end of this event, as soon as the character dies, I'm going to get the health bar and set its visibility. Set visibility to hidden. So now if I compile and launch the game, if I attack Rampage, oh, now he dies instantly because I modified the process damage event. I'm going to reconnect this max node here. Now if I compile and launch it for real, if I attack Rampage, you can see that the health bar correctly updates itself. Great, so now we are going to take things a bit further by animating the red part of the health bar to visualize the amount of damage dealt with each hit. So back in my WBP health bar, I'm going to create a new event, custom event, called Update Damage Animation. This new event will make the hit level always try to reach the fill level all the time. So to do this, I'm going to add a float input called delta seconds. Then I'm going to call set hit level here to set the level of the red part of the health bar. Then I'm going to pull off a f interp2 node from the value input. I'm going to set the interrupt speed to 5. I'm going to connect the delta seconds in the delta time. And then in current, I'm going to plug hit level and connect fill level to target. So if you don't know what the F interrupt node is, it changes the hit level so it smoothly catches up to the fill level based on how fast we tell it to go with the interrupt speed parameter. So now to use this new event correctly, you need to call it in the event tick and connect the delta time of the event tick to the delta seconds. So right now I'm going to right click and call event tick. Then I'm going to call update damage animation and connect delta time to delta seconds. So now I'm going to compile. And if I launch the game and try to attack Rampage, you can see that the red part of the health bar animates whenever he receives damage. So to make it more obvious, I'm going to open Rampage. I'm going to go to his health system, and the health bar size, I'm going to give it a big size, like let's say, for example, 200, so that the change is more obvious. So here, if I launch the game and attack Rampage, you can see that the health bar animates itself correctly when Rampage receives damage. Okay, so the health bar animation works like a charm, and that's great. But the problem is that since update damage animation is called in event tick, it's getting called every frame, even if the health points of the damageable character don't change. Needless to say, here we only have a single damageable character in the world. But if we had a lot more characters that weren't taking any damage, the overhead caused by event tick would quickly become a serious problem. So to fix this, I'm going to teach you a cool technique that I like to use a lot. So first, I'm going to create a new event dispatcher named onDamage Anim tick. I'm going to add a float input and rename it to delta time. Then I'm going to compile, and then in the event tick, I'm going to delete the call to update damage animation and replace it with a call to our dispatcher. I'm going to connect this like here and here. So we've already used the dispatcher earlier in this tutorial, but to explain it again in a simple way, you can think of this dispatcher as a newsletter we created that sends a new email to everyone who's subscribed every frame when we call it. If no function or event is subscribed to this newsletter, then calling it costs almost nothing. However, if an event is subscribed to it, calling the newsletter is just like calling the event. So now I think that you know where I'm going with this. Here, whenever we want to play the damage animation, we are going to subscribe our update damage animation event to this newsletter. Then, as soon as we don't need to play the animation anymore, we just have to unsubscribe our event from this newsletter to prevent the overhead. Okay, so first, I'm going to create a new event, new custom event called set damage animation enabled. I'm going to add a new Boolean parameter and rename it to enable. Then I'm going to add a branch. And then if we want to enable the animation, I'm going to get the onDamage Anim tick and bind an event. I'm going to call create event, and I'm going to bind the update damage animation. Okay, so when we call set damage animation enabled, it will enable or not the damage animation with the dispatcher. So if we want to enable the damage animation, we subscribe the update damage animation to onDamage Anim tick. Then if we want to disable the damage animation, we are going to unbind the onDamage Anim tick from the update damage animation. So what we want to do is enable the damage animation every time fill level is updated. Okay, so here I'm going to go to set fill level, and here I'm going to call set damage animation enabled. So whenever the fill level will be updated, the hit level will try to reach it. Then once the damage animation is active, so here with the update damage animation, we are going to check if it has reached the fill level, and if it has, we are going to disable the animation. So to do this, I'm going to get the hit level and the fill level, and then I'm going to compare them. Are they equal to each other? I'm going to put that in a branch. I'm going to connect this here, and then as soon as they are equal to each other, I'm going to call set damage animation enabled and leave it to false to disable the animation. So now if I compile, save and launch the game, the damage animation still works, except that this time it's more optimized. Okay, so now our system is slowly taking shape, and from this section on all the way to the last one, we are going to make our attacks feel more impactful by gradually adding juice to them. So lately, I've been watching a lot of videos from Masahiro Sakurai, the creator of Smash Bros, where he explains how to juice up combat. According to him, there are many techniques we can use, and the first one we are going to implement is called Hit Stop. Hit Stop consists of freezing both fighters when a hit happens to make it feel more impactful. And in this section, we are going to create a new component for triggering hit stops. So here I'm going to create a new actor component by right-clicking, select Blueprint class, actor component, and rename it to AC_hitstop. Then I'm going to open it. And this component will be added to characters and will be used to trigger hit stop on them. So first in the begin play, I think you're used to that now, I'm going to call get owner. Then I'm going to cast to character. And then I'm going to promote this to a new variable called character actor. Then I'm going to create a new event called begin hit stop. This event will freeze the character. I'm going to add a float input to this event called duration, which will define how long we want the hit stop to last. So next, I'm going to pull off a set custom time dilation from the character actor. Set custom time dilation. For those of you who don't know this node is used to speed up or slow down time for a specific actor. Here I'm going to set its value to 0 to completely freeze the character in time. Then I'm going to add a set timer by event node, timer by event, and connect the duration parameter of the event to the time input of the set timer by event node. Now I'm going to create a custom event called end hit stop. Then I'm going to compile, and then I'm going to drag a wire from the event and call create event and select the end hit stop so that we can move it freely in the graph. And finally, in the end hit stop event, I'm going to call set custom time dilation again, but this time I'm going to set it back to 1 so that the actor can move again at normal speed. Okay, so to sum up what we've just implemented, when begin hit stop is called, it freezes the character in time for a set duration. Then once the timer reaches 0, end hit stop is called and the character can move again at normal speed. so now we are going to try it out. First, instead of adding our hit stop component to the actors directly in their blueprint, I think you know the gist. We are going to add our component using code. First, let's go to our AC combat system to add our hit stop component to our character. So in the begin play, I'm first going to check if the character already has a hit stop component. This can happen, for example, if our character has both a combat system component and a health system component. So I'm going to get the character actor. I'm going to call get component by class. I'm going to set it to AC hit stop. Then I'm going to call isValid on it. That way, if isValid returns valid, then that means that the character actor already has a hit stop component. If it's the case, then I'm going to promote the component to a variable called hit stop comp. I'm going to connect this, and if the character doesn't have a hit stop component, I'm going to get the character actor and call add component by class. Okay, this will add a new component to the character actor, and then I'm going to set this new component to AC hit stop, and then promote this new component to the hit stop comp variable. Okay, so now I'm going to do the same thing for the AC health system. I'm going to select these nodes, copy them, Ctrl+C, open the AC health system, and then in the begin play of the AC health system over there, I'm going to paste the code. So here I'm going to right click on the hit stop comp to create the variable. I'm going to compile and save. So now whenever we add a health component to a character, it will get a hit stop component, and whenever we add a combat component, it will also have a hit stop component. So now I'm going to go to my AC combat system, and I'm going to go to the apply damage to actors function. This function is where the hit stops are going to be triggered. Why? Because this is where each actor hit by the attack is accessible. So here, just after the hit actor is added to the array, I'm going to trigger a begin hit stop, and I'm going to set its duration to 0.5. Then I'm going to get the hit actor. I'm going to get component by class to make sure that it does have hit stop component. I'm going to check if it's valid, is valid. If so, that means that the character has a hit stop component. And so I'm going to call begin hit stop on it and set this begin hit stop to 0.25. So now if I compile and launch the game, you can see that if I attack Rampage, both characters freeze on hit, which adds a lot more juice to the impact. Okay, so before moving on to the next section, we are going to apply a small suggestion from Masahiro Sakurai. In fact, Masahiro Sakurai says that the hit stop looks cooler if you freeze the hit actor, and if you apply a strong slowdown to the attacking actor. So now we are going to implement this by going in the AC hit stop and adding a new float input called time dilation. This float input will apply time dilation by default equal to 0, and with our attacker we are going to set it to something like 0.05 to slow it down a lot. So now I'm going back to my AC combat system, and then I'm going to change the time dilation value of the attacking actor to 0.05 instead of 0. That way the character's animation will play at 5% rate. So now if I compile and launch the game, you can see that the effect is indeed a bit cooler than before. Okay, so in this section, we are going to continue adding more juice to our attack, this time by shaking the two actors when a hit happens to increase the feeling of impact even more. So, a quick note before implementing the hit shake, instead of shaking the actors, we are going to shake the skeletal meshes. Why? Because if we shake the actors, their capsules will shake too, which can make it harder for the next attack to land. So here, I'm going back in my AC hit stop, and I'm first going to store the character's mesh in a variable. Here I'm going to get mesh. Then I'm going to promote this to a variable called mesh. I'm going to connect this here. And I'm also going to get relative location of the mesh and store it in a variable called mesh default relative lock. Okay, so I'm going to store this relative location because we are going to shake the meshes instead of the actor. So now we are going to code an event for shaking the mesh. To do this, I'm going to add a set timer by event in the begin play. Then I'm going to set its time to 0.5. I'm going to enable looping, then pull a wire from the event parameter and add a custom event. I'm going to rename this custom event to apply mesh shake step. Now we are going to make it so that with each new call of apply mesh shake step, the mesh moves left, then right, then left, and so on. To do this, I'm going to call set relative location on the mesh variable, set relative location. Then I'm going to enable the teleport parameter so it ignores collisions while shaking. Next, I'm going to pull an add node from a get mesh default relative location and connect the result to the new location. So now let's say that when I call the event, I want the mesh to shake 20 units to the left relative to the default relative location, then 20 units to the right. To achieve this, first I'm going to create a float variable called shake amplitude. I'm going to change its type to float. I'm going to compile and set its default value to something like 20 because we want to shake the mesh 20 units. Then I'm going to create another float variable called offset direction. I'm going to compile and set its default value to 1. So offset direction will make it so when it's equal to 1, it's going to shake right, and when it's equal to -1, it's going to shake left. So now back in my apply shake mesh step event, let's say that I want the character to shake along the relative x-axis. To do this, I'm going to split struct pin here. I'm going to multiply the shake amplitude by the offset direction. And then I'm going to connect the result in the x-axis. Then, by the end of the event, I'm going to get the offset direction and call negate float. That way, when the offset direction will be equal to 1, calling this node will make it equal to -1, and so on. Now I'm going to compile and save. Now if I launch the game, both characters do shake, but if I align the camera with their relative x-axis, they don't seem to shake that much anymore. So to fix this, we want to make them always shake from left to right relative to the camera view, so it looks like they are always shaking left and right, no matter the angle we are viewing them from. To achieve this, we are going to summon the math gods to help us. It might seem scary, but don't worry, it won't be hard to understand. So first, I'm going to get the player controller. Then I'm going to call get player camera manager to get a reference to the current camera. And then I'm going to call get actor right vector on this to get the direction pointing to the right of the camera. Now, since we are moving the meshes in their local space, we need to convert this vector from world space into the character's local space. To do this, I'm going to call get actor transform on the character actor variable, and then I'm going to call an inverse transform direction from it and connect the camera's right vector to the direction input. And voila. By doing this, you now have the camera's right vector expressed in the character's local space. So next, since we want our character to shake only left and right and not up and down, I'm going to remove the Z component from this vector by right-clicking on its return value, split struct pin, and then I'm going to call a make vector, and I'm going to connect only the X and Y components of the vector. So finally, I'm going to multiply this new vector by the result of the shake amplitude multiplied by the offset direction. And then I'm going to recombine, I'm going to add this to the mesh default relative location variable. So now let's launch the game. I'm going to compile, and if I launch the game, you can see that no matter the angle that I'm viewing a character from, it's always going to shake left and right relative to the camera view. Okay, so now that our shake logic is finished, instead of starting to shake the character directly at begin play, we are going to shake only during the hit stop. So before implementing that, I'm going to pull a wire from the event input of the set timer by event node and call create event. Then I'm going to set it to apply mesh shake step so that I can move the apply mesh shake step wherever I want. Next, I'm going to disconnect the set timer by event from the begin play and connect it to the begin hit stop event. Here, I'm going to get the begin hit stop, connect this to the set timer by event. Okay, then I'm going to store the return value of the set timer by event in a variable called shake timer, so that I'll be able to stop the timer and therefore the shake whenever I want. Great, I'm going to compile, and now I'm going to add two float parameters to the begin hit stop function. The first one is going to be called shake speed and control how many times the mesh moves left or right per second. And the fourth one is going to be shake amplitude, which will control how far the mesh moves left and right during the hit shake. Then I'm going to set the value of the shake amplitude variable to the value of the shake amplitude parameter by dragging a set variable here and connect it like this. And finally, I'm going to divide 1 by shake speed to get the time between each shake step and connect it to the time parameter of the set timer by event node. So before testing it in the end hit stop event here, I'm going to make sure to stop the shake timer and to get the shake timer and call clear and invalidate timer by handle. That way the character will stop to shake. And then I'm going to set the mesh relative location to the default relative location. Of course, I'm going to check teleport as usual, and then I'm going to set the custom time dilation back to 1. So I'm going to compile, and now in the AC combat system, we are going to change the hit shake parameters. So for the hit actor, so this one, I'm going to set shake speed to 30 and shake amplitude to 20. As for the attacking actor, I'll set shake speed to 30 and shake amplitude to just 1. Why set it to just 1? Because according to Masahiro Sakurai, a good practice is to make the hit actor oscillate more than the attacking actor to better highlight which one is receiving the damage. So now if I compile and launch the game, you can see that the characters do shake on hit. So here it may look like they are shaking too much, but don't worry, it won't be as noticeable once we add the other techniques to give the impact more juice. Okay, so another tip from Masahiro Sakurai about the hit shake is to make it start strong, then gradually make it less intense before the complete stop. So to achieve this, we are going to use something we already used earlier, curves. So I'm going to right-click in the content browser, select miscellaneous, and click on curve. Then I'm going to select curve float, click on select, and rename it to curve underscore hit stop shake intensity, and open it. So here I'm going to press enter to add a new key, and I'm going to set its value to 0 and 1. Then I'm going to press enter again, and I'm going to set the value of this new key to 1 and 0.2. Then I'm going to press Ctrl plus A, and then press F to fit the selected keys in the view. So here the x-axis represents the hit stop duration, 0 is the start and 1 represents the end. And as you can see, the shake starts at maximum intensity of 1 and loses intensity down to 0.2, which represents around 20% of the maximum intensity. It's great, but I don't want a linear progression. Instead, I want an ease-in, ease-out curve, which starts slow and accelerates and finishes slow. So to do this, I'm going to press Ctrl plus A, then click on the linear button here, and I'm going to select Auto. That's exactly the curve shape that I want. So now I'm going to show you how to use it. I'm going to save it and close it. And then I'm going to go to my AC hit stop. I'm going to create a new variable called shake resolve. I'm going to change its type to curve float. I'm going to compile, and then I'm going to set it to the curve we just created, curve hit stop shake intensity, this one. I'm going to compile. Then in the begin hit stop event, I'm going to store the second timer into a variable called hit stop timer, because I'll need to get the time elapsed since the start of the timer. Then I'm going to store the duration parameter of the event, promote to variable, in a hit stop duration variable. I'm going to set it here. And next I'm going to go to the apply mesh shake step event. And here I want to adjust the strength of the shake by multiplying the offset by the value of the curve at that moment in the hit stop. So to do this, I'm going to call get timer elapsed time by handle on the hit stop timer. Then I'm going to divide this value by the hit stop duration to normalize the current time in the hit stop to a value between 0 and 1. Then I'm going to call get float value on the shake resolve variable and connect the result of the division in the time input. Then I'm going to connect the float value here. Okay, so now I'm going to compile, and that way when the hit stop starts, it goes strong for the beginning and then slows down. So now if I launch the game, you can see that the shake looks much cleaner than before. So before moving on to the next section, since the tutorial is starting to become really long, I won't do it, but if you want to modularize everything, you can add the hit stop info directly into the advanced attack structure we created earlier. That way you'll be able to set per attack hit stop parameters and adapt them based on the attack power, etc. It will be cool to do, and you'll end up with an easily reusable system with a lot of parameters to tweak. Okay, so now let's tackle a classic in fighting games, camera shakes. For those of you who don't know what camera shakes are, they are simply a way to adding juice to attacks by shaking the camera during the hit stop to make the impact feel even more powerful. So achieving this is going to be quite easy, since all we have to do is right-click in the content browser, select Blueprint class, search for camera shake, Then I'm going to choose Camera Shake Base. I'm going to click on Select. I'm going to rename it to CSB for Camera Shake Base. Cam, Hit, Shake, and open it. So here in the Details panel, I'm going to set the root shake pattern to Berlin Noise Camera Shake Pattern. So doing so will make the camera shake erratically thanks to the Berlin noise. Then I'm going to unfold it and then unfold the location and timing. The location parameters define how the camera is going to move during the shake. Here I'm going to set the amplitude multiplier by 20, so the camera will oscillate by 20 units in all directions. Then I'm going to set the frequency multiplier by 20, so it will oscillate 20 times per second. So you have the same parameters for rotation and FOV, but I won't change them. Instead, I'm going to adjust the timing parameters. I'm going to set duration to 0.2 seconds, so the shake will last 0.2 seconds. Then I'm going to set blending time to 0 because I don't want the shake to start slow. And finally, I'm going to set blend out time to 0.1 to make the shake gradually resolve itself during the last 0.1 seconds of the shake. So great, so now that the camera shake is correctly set up, I'm going to compile and save, and all we have to do is trigger it at the same time as the hit stop. So I'm going to go to my AC combat system. In the apply damage to hit actors function, I'm going to get the player camera manager from the get player controller node. I'm going to right click, get player controller, and then I'm going to get player camera manager. Then I am going to call start camera shake. I'm going to set the shake class to CSB cam hit shake. Then I'm going to compile, save, and if I launch the game, it's subtle, but you will see that the camera shakes a bit, which adds a bit more to the impact. In Smash Bros, when a character is hit by an attack, in addition to the hit stop and the hit shake, there's also what's called the flashing effect, which makes the character blink to increase the feeling of impact even more. To achieve this effect, we are going to create a special type of material called an overlay material that will be added on top of the character's base material to create a white layer over it. So here in the content browser, I'm going to right click and create a new material that I'm going to call m_hit flash. I'm going to open it. And here in the details panel, I'm going to set the blend mode to additive. And the shading model here, I'm going to set it to unlit. Since it's a flashing effect, it won't cast shadows, so I'm going to uncheck the Cast Ray Traced Shadows option here. Okay, so here, the emissive color, I'm going to set it to something like pure white. Let's put it to pure white here and press OK. So I'm going to apply and save. And now I'm going to show you how overlay materials work. So to do this, I'm going to open my BP Wukong. I'm going to go to the viewport and select the mesh. Then in the details panel, I'm going to search for overlay. Here, if I assign my hit flash material to the overlay material slot, you can see that the character turns white, which is really cool because before overlay materials, we had to directly change the character's material to achieve something like this. So now we just have to make one material and it can be added on top of any other material and it will work as expected. So before moving on to the code part of the hit flash, I'm going to remove the hit flash material here. Then I'm going to open my BP Rampage because I want to show you something. Here in the BP Rampage, I'm going to go to viewport and select mesh. And here, if I search for overlay material and set it to hit flash, you will see that it does work, but some parts of the mesh are not covered by the overlay material. This is because the base material of Rampage uses WPO, or World Position Offset, which is a feature that modifies the shape of the mesh. And since our overlay material can't access the WPO, it only covers what it's supposed to be the real shape of the mesh, without any displacement applied to it, of course. So to fix this, I'm going to go to my Hit Flash material, and then I'm going to add a vertex normal WS, vertex normal word space. Then I'm going to multiply this by a scala. I'm going to press S on my keyboard and click in the graph to create a new scala parameter. I'm going to rename the scala to inflation intensity, and I'm going to set its value to 2. I'm going to plug this in the multiply node, and then I'm going to connect this multiply node to the world position offset WPO. So now I'm going to click on apply and save, and doing this will make the white part of the mesh grow as if it's inflating. The larger the value, the more the mesh will grow. So here, if I go back to Rampage, you can see that it's not perfect, but it's a simple tweak that can make the result a bit better. So now if I put a really big value in the inflation intensity, let's say for example 5, and apply, if I go to Rampage, you can see that it looks like the Michelin character, but at least everything is covered by the overlay material. So it's up to you. You can test it and choose the right value for your character. Now, back in my Hit Flash material, I'm going to modify it so that instead of every part of the mesh becoming white, only the contour of the character will be brighter than the rest. To do this, I'm going to connect a Fresnel node to the emissive color. I'm going to click on apply, and if you have a look at Rampage, you will see that the effect is already a bit more interesting than just pure white. Then, to add more control over the effect, I'm going to connect the Fresnel node to a power node. The power node, then I'm going to right click on the exp input and promote it to a parameter called contrast. So as its name suggests, this value is going to increase or decrease the contrast of the effect. So here I'm going to set its default value to 1.8, I think. And then I'm going to call a multiply node from the power node, right click on B, and promote it to another variable called intensity. The intensity here is going to control the intensity of the glow effect. I'm going to set this value to a default of 10. Finally, I'm going to add a color parameter named color by pressing V on my keyboard and clicking. I'm going to rename this new color parameter color and set its default color to pure white. And to press OK and multiply this color by the intensity. I'm going to connect this to the emissive color, and now I can control the contrast of the effect, the intensity of the glow, as well as its color. So I'm going to click on apply, and now if you have a look at Rampage, it's glowing a bit more than earlier in this video. So now I'm going to add the blink effect to the material. So here I'm just going to add a comment. I'm going to select this, press C on my keyboard, and write add a rim light effect. So now to add the blink effect to the material, I'm going to add a time node. Here, I'm going to add a time node, and this node will give us the elapsed time. Then I'm going to multiply this by a value that I'm going to promote through a speed parameter. So I'm going to set it by default to 1, but increasing the speed value is going to make time run faster in the material, which in turn will make the blinking faster. After this, I'm going to add a sine node. The sine is going to make the value oscillate between -1 and 1 over time. If I multiply this output by 0.5, I'm going to make the value go from minus 0.5 to 0.5, and then I'm going to add 0.5 so that the value will go from 0 to 1. Okay, so just a quick recap. Here, the value is going from minus 1 to 1. Here, the value, we modify it by multiplying it by 0.5, so the result gives minus 0.5, 0.5. And finally, we add 0.5, so the result gives 0, 1. Okay, so now what we've done is remap the oscillation between 0 and 1. So finally, I'm going to add a round node to this, which will round the result of the add node to convert the smooth 0, 1 oscillation into a clean on-off value, which will make our character blink. So here, if I click on the play button, you can see that we do have the blinking effect. So now I'm going to stop previewing the node, and I'm going to connect the round node to the opacity parameter so that the material alternates between fully transparent, 0, and fully opaque over time. So now you can see here that the material does blink. Now I'm going to click on apply and save, and if I open my BPRM page again, you can see that it blinks, which is really cool. And now I'm going to remove the overlay material from the mesh because we are going to add it through code like usual. I'm going to compile and save. Now back in my hit stop component, in the begin play, I'm going to create a dynamic material instance for my hit flash material by calling create dynamic material instance. I'm going to select my hit flash parameter as a parent, and I'm going to store this into a variable called hit flash material. Then after that, I'm going to access the speed parameter of the material, this one, which, if you remember well, will help us accelerate or decelerate the blink. So here, I'm not setting this to a bigger value. Let's say just for example, 2. It's going to blink faster, but I don't want to to create a seizure on YouTube, so I'm going to set it to 1 and change this value through the code. So here, I'm going to pull a wire from the hit flash material, set scalar parameter value. Then here, I'm going to call my parameter speed to access the speed parameter of the material and set its value to 20, so it will blink really fast. Then I'm going to compile, and in the begin hit stop event, I'm going to add a new Boolean input. This new Boolean input, I'm going to add it here. It's going to be called flash, and will tell if the flash should be enabled for a character or not. So if you remember well, only the hit actor flashes when the hit stop begins. So I'm going to compile, and here I'm going to promote the flash parameter to a new variable called flash. I'm going to set this value here at the beginning of the hit stop. Then I'm going to compile and save. Then at the end of the begin hit stop event, I will check if I want the flash to happen or not. To do this, I'm going to get the flash variable, right click on it, select convert to branch. I'm going to connect this to the end of the begin hit stop event. And then if flash is true, then I'm going to get the mesh of the character and set his overlay material to the hit flash material. Okay, so when I trigger the hit stop on this character, if I need to flash, then I'm going to add the overlay material to it. I'm going to compile, and finally in the end hit stop event, when the hit stop finishes and the time dilation is set back to 1, convert to branch. If flash is true, we are going to remove the hit flash material from the mesh overlay material. So I'm going to get the mesh, set overlay material, and I'm going to leave the new overlay material empty. That way we will remove the overlay material that we added earlier. So now I'm going to press compile, save, and I'm going to open my AC combat system, and go to the apply damage to hit actors. So now you can see that our begin hit stop nodes have the new flash parameter. So here the attacking actor doesn't have to flash, but the hit actor needs to flash. So I'm going to check this option. And now if I launch the game, you can see that Rampage flashes whenever I hit it with my attacks. So just to show you how it works, I'm going to add a new slow-mo console command to my code. I'm going to slow the game down. And now if I attack, you can see that the character shakes and that the hit flash happens. Okay, so our system is almost done, and in these last two sections we are going to use the final technique to juice up our attack, spawning Hit VFX. So here I'm going to open my Hit VFX image, and here you can see that I have this free PNG representing a Hit VFX that I downloaded on internet for free. So this is similar to the ones you can see in some comic books. And in this section, we are going to spawn this image in a particle system at the hit location of any attack and make it quickly grow before disappearing. I wanted to do this because I would like to replicate what you could see in a comic book inspired retro game that I really liked when I was a kid, and which is called, I think, Comics Zone, which was released on the Sega Genesis. So first, I'm going to create a new material called m_hit_VFX. Then I'm going to open it. And here I'm going to change the blend mode to translucent, set the shading model to unlit, and uncheck the cast ray traced shadow because this is going to be a particle, so it won't cast shadows. Then I'm going to drag my Hit VFX texture into the graph, and I'm going to multiply its RGBA output by a particle color node. By doing this, I will be able to change the tint of the texture later in our particle system if I want. So next, I'm going to add a brand new node in Unreal Engine 5.7, which is called Convert. So as its name suggests, this allows us to convert different variable types into one or several or other types. So what I'm going to do with it is break the RGBA input into RGB and A output. So here I'm going to add an input of type vector4 for RGB and A. I'm going to add an output of vector3, so RGB, and another one of scalar, another scalar type output. Okay, so then I'm going to connect the input components to the corresponding output components. I'm going to get the R, plug it to R, the G, connect it to G. I'm going to connect the B to B, and the A to the scalar output. Now I'm going to connect the multiply to the convert, and this will convert into a color and an alpha that I can plug to emissive color and opacity. So now if I change the shape to a plane, you can see that we have our sprite that is correctly working. I'm going to click on apply and save. Okay, so we are going to add more functionalities to this material later in this tutorial, but for now I'm going to go to my content browser and create a new Niagara system. I'm going to select Niagara system here, and then in the window that opens, you can see that we have a lot of templates that you can start from, and the one I'm going to choose is called Simple Sprite Burst. Simple. Okay, so I'm going to search for it. Simple Sprite Burst. I'm going to select this template, then click on Create. Then I'm going to rename this Niagara system to ns_hit_VFX and open it. So here I won't go into detail about how Niagara works, but just so you understand what we'll be doing here, this system spawns a simple sprite that you can see here in the viewport, which is basically a flat 2D image with a defined lifespan. So here we are going to replace the material of that sprite with the one we've just created, then change a few parameters in the particle spawn category, which runs once, here the particle spawn category, which runs once when the particle appears. as well as particle update, which works like the event tick of a particle. So now, if you want me to make a complete introduction to Niagara, Unreal Engine's visual effect system, in a future tutorial, feel free to tell me in the comments and I'll see what I can do. So now in the render category right here, so I'm going to select the sprite renderer, and here I'm going to change its material to our Hit VFX material. I'm also going to change the sprite facing mode parameter, this one. I'm going to change it to face camera so that the sprite will constantly look at the camera. So now you can see that we have our particle here, but the problem is that it's a bit too small. So I'm going to go to the initialize particle of the particle spawn category. So particle spawn category is like the begin play of a particle. What do we do when the particle spawns? I'm going to select initialize particle, and here I'm going to set the sprite size mode here to random uniform. Then set the min to 200 and the size max to 250. This will make each particle spawn with a random size between 200 and 250. Then, to add more randomness to the emitter, I'm going to give each sprite a random rotation by setting the sprite rotation mode here. The sprite rotation mode, I'm going to set it to direct angle degrees. And then I'm going to click on the arrow here. Instead of giving a degree like 45 or 90, I'm going to click on this small arrow here. This is what I really like about Niagara, because we can do a lot of things. I'm going to click on this small arrow and select random range float. I'm going to add a random range float module. I'm going to set the minimum to -45 and the maximum to 45, so that each particle will spawn with a random rotation between -45 and 45 degrees. I'm going to save, and then to increase the feeling of impact, we are going to make the particle quickly grow on spawn, so that as if it was exploding out of nowhere. To do this, I'm going to add a scale sprite size to the particle update category. So here we have the particle update. This is like an event tick of the particle. So as soon as we've set up the spawn, the begin play, then the event tick is going to be called every frame. So here in particle update, I'm going to click on the plus sign and add a scale sprite size node. This will allow us to change the size of the sprite during its lifetime. So here you can see that the sprite linearly grows from 0 to its max size, thanks to the curve that we can see right here. 0 represents the size it has when it spawns, and 1 represents the size it has, the scale it has when it's going to die. So here I'm going to choose one of the templates that you can see right here. We have curve templates. I'm going to click on the hamburger sign and select the ease in curve, this one. That way, the sprite will quickly grow and grow slower when it's close to the end of its lifetime. So that's great, but now the effect is a bit too slow and the particle stays visible for too long when it's supposed to stay on screen for only a few milliseconds. So to fix this, I'm going to my initialize particle module. I'm going to set the lifetime to the lifetime that you can see right here, lifetime parameter. I'm going to set it to 0.3 so that the particle dies after 0.3 seconds. Then I'm going to select the emitter state module in the emitter update category and set its loop duration to 0.3. That way the emitter will die also after 0.3 seconds. So now that you can see that the particle spawns and dies really fast. And now I'm going to make it so the fade out doesn't happen too quickly. Here, I'm going to go to the scale color of the particle update, and this curve represents the alpha, the translucency of the particle that goes from completely opaque to completely transparent. Instead of getting this curve shape, I'm going to select the drop-off template, which is the third one going from the left. So now you can see that the particle only starts to fade out when it's close to the end of its lifetime. I'm going to save and click on compile. Great, so now to finish with this particle system and optimize it a bit, I'm going to select the emitters properties right here. I'm going to set the sim target to GPU compute sim to run the particle system on the GPU instead of the CPU. And then I'm going to set the calculate bounds mode to fixed, which is required for GPU simulation to work. I'm going to compile and save, and there you go. Now that the particle system is finished, I'm going to show you how to spawn it at the hit location of each attack. So to do this, it's really easy, since all I have to do is go to the apply damage to hit actors in the AC combat system. Here, I'm just before the begin hit stop here. I'm going to call a node called spawn system at location. This will spawn a Niagara system at the location that we specify. So here, I'm going to make some place, and then I'm going to set the system template to our NS Hit VFX. And then I'm going to get our hit result variable, which, if you remember well, is the hit result that happened when the attack was validated. So here I'm going to get a break hit result from this node to show all its parameters. And then I'm going to connect the impact point to the locations to get the exact location of the hit of the attack and spawn a particle system at that location. So now I'm going to compile and save. And if I launch the game, you can see that, that it works correctly, that the particle appears each time I land an attack on Rampage. Okay, so here if I launch the game and slow it down using the slow-mo console command, you will see that when I chain attacks on Rampage, the sprite particles sometimes spawn between the two characters and get cut off by their bodies. You can see right here. What I'd like to do is make it so the VFX always appears between the two characters above Rampage and below Wukong. So to do this, first I'm going to open my VFX material, my Hit VFX material. Then in the details panel, I'm going to search for a parameter called disable depth test. I'm going to check this disable depth test parameter. I'm going to apply. And now if I launch the game, as you can see, the sprite now appears above everything, even the player. Of course, it's not exactly what we want, so I'm going to show you a relatively advanced technique called the depth stencil to make the player appear above the particle system. The idea is really simple. We are going to take Wukong and put him into a special rendering pass and make that pass draw on top of the particle system. So to do this, first I'm going to go to Edit, here, then select Project Settings. And here I'm going to search for custom depth. I'm going to set the custom depth stencil pass parameter to enabled with stencil. Then, to show you how it works, I'm going to select Wukong in the viewport. And here on the right side of the screen, I'm going to put myself on the left side of the screen. I'm going to search for render, custom, and I'm going to enable the render custom depth pass for the mesh. So here, by doing this, I'm putting the mesh in a special pass called custom depth. So to visualize the custom depth pass, I'm going to click on the lit button here. I'm going to select buffer visualization, buffer visualization, and here I'm going to click on custom depth. Here you can see, I don't know if it's visible, but you can see that only Wukong appears in this render pass because it's the only actor that we added to the render custom pass. So now If you remember earlier, just before, in the project settings, we enabled the custom depth pass with the stencil option. So to put it simply, a stencil is like having multiple numbered custom depth layers where we can place specific actors to apply specific logic to them. So here I'm going to select Wukong again and search for stencil in the details panel. I'm going to set the custom depth stencil value to 1. Now, if I change the buffer visualization to custom stencil, you can see that Wukong appears on screen with 1 written on it because he was placed in the stencil 1 render pass of the custom depth pass. Okay? As usual, instead of setting custom depth and stencil directly on the actor, I'm going to set them in code. So here I'm going to set back the custom depth stencil value to 0. Then I'm going to search for custom depth. And I'm going to uncheck the render custom depth pass. Now, if I have a look at the viewport, you can see that Wukong is no longer in the custom depth or the custom stencil. So now I'm going to set back the viewport to lit to show everything normally. And to do this, to set the custom depth and stencil directly through code, I'm going to go to the AC combat system and search for the begin play, which is right here. So here in the begin play, before we create the hit stop component, we are going to get the character mesh variable here. And then I'm going to pull a set render custom depth. I'm going to set it to true and pull another node called set custom depth stencil value and set it to 1. So here I have this and this, and I'm going to set the custom depth stencil value to 1. This is going to do the exact same thing that we've just done in the viewport. Okay, so great. Now that our actor has been placed in the custom depth pass as well as in the stencil pass, we are going to modify the Hit VFX material to make it transparent wherever the actor is present in the stencil pass number 1 that we set right here. In other words, I want to make the player appear above the Hit VFX. So to do this in my Hit VFX material, I'm going to add a node called Scene Texture. We've used it a lot in my toon shading and outline shading tutorials. So I'm going to select the scene texture node and set its ID to, I think, custom stencil. I'm going to select custom stencil so we can access the custom stencil render pass. Then I'm going to add another convert node, not comment, right click, convert. I'm going to call it convert node, which is going to get a vector 3 and turn it into a scalar. I'm going to connect the R to the scalar output and connect the color right here. So here, the convert, for those of you who don't know, who've never used this node, you can also call component mask and just check R, and this will do the exact same thing. It's just like when there's a new node, I like to use it a lot to be used to it. So now I'm going to delete the component mask. And next, I'm going to add a saturate node. I'm going to add a saturate node, which will clamp the value between 0 and 1 so that each pixel stencil always has a value of 1. So here, this custom stencil scene texture is going to show 1 for Wukong since it's in the layer 1 stencil layer, in the stencil layer 1. So if I put something like 5, this is going to return 1. If I put something like 0, this is going to return 0. Okay? So after that, I'm going to add a 1 minus node. The 1 minus node is going to invert the result. Instead of getting 0 for a pixel that is not in the stencil and 1 for a pixel that is in the stencil, Here, if a pixel is in a stencil, it will return 0, and if not, it will return 1. And finally, I'm going to multiply the result of the 1 minus node by the alpha output of the convert node we created earlier. So here I'm going to call a multiply on the scalar output of the convert and connect the 1 minus node here. I'm going to plug this into the opacity. And now if I click apply and save and try to launch the game, you can see that the Hit VFX appears between Wukong and Rampage. So here, even if it seems to work, I still have a problem with the particle VFX. Here, if I place Rampage between Wukong and the camera, I'm going to slow down the game. If I attack, you will see that the particle is cut out wherever Wukong is, even if he's behind the character. So now you can see the shape of Wukong through the particle sprite. Okay, so of course this is something that we don't want. So in my Hit VFX material, we are going to hide the particle only if there's an actor in the stencil and if that actor is also visible in the main render pass and not behind something. If it isn't visible in the main render pass, that means it's behind something, in that case Rampage. So in that case, we won't hide the particle. So to do this, I'm going to add another scene texture node. And this time, I'm going to set this one to custom depth. Custom depth. Then I'm going to convert its color to a scalar. Convert. I'm going to add vector 3. Convert its color to a scalar here. And doing this, if a pixel is in the custom depth, so custom depth, custom stencil is the same, it will return its distance from the screen. Then I'm going to duplicate these two nodes and change the new scene texture to custom stencil. So I have the custom depth and, no, not the custom stencil, sorry, I'm going to set it to scene depth. Scene depth to get the distance of all pixels from the screen. So here I get the distance of the pixels that are in the custom depth, and here I get the distance of everything on the screen, even the ones that are in the custom depth. Next, I'm going to add a step node. Step node, and connect the custom depth to Y and the scene depth to X. So this bit of logic makes it so that if a pixel has the same value in the custom depth and the default scene depth, in other words, if a pixel is visible both in the custom depth and in the default scene depth, it will return 1, and if not, it will return 0. Okay? And finally, I'm going to multiply the output of the step node by the output of the saturate node right here. Then I'm going to put this in the 1 minus node. Okay, so multiplying these values together, so all of these three values, if we multiply these three values, it lets us check whether a pixel or something, a character, is visible in the custom depth, the scene depth, and the custom stencil. If it is, the multiply node here will return 1. If it's missing from any one of those passes, it will return 0. Why is it useful? Because if I play, let's put it as it was, if I play the game, here, Wukong is visible in the custom stencil, the custom depth, and the scene depth, because he is on screen. Here, if I put the camera like this, Wukong is visible in the stencil and in the custom depth because it's the only actor here that's put in the custom depth. However, in the scene depth, the main depth pass, it doesn't appear because Rampage is in front of it, and we can't see Wukong, so this code will return 0. So now I'm going to connect it back to the 1- node. And now that the material is done, I'm going to click on Apply, Save, and if I launch the game, you can see that if Wukong is in front of the camera, then the Kapow particle is going to be cut out. And if there is something between Wukong and the particle is just going to be shown as it is supposed to be above the Rampage character. Okay, so congratulations, the implementation of our systems is done, and to finish the tutorial, I'm going to show you how to easily reuse it on other characters. So, first I'm going to delete Wukong and Rampage from the level, and then I'm going to go to my alt characters folder, and I'm going to drag BP Crunch in the level, and BP Still in the level. So these characters are two characters from the marketplace. They are free too, and they are characters from the game Paragon by Epic Games. I'm going to turn Still here. They are totally free, so you can get them for free on the Fab marketplace. And now if I launch the game, it's as if I were starting the tutorial all over again, except that this time I'm controlling Crunch, and the damageable character is Still. So now let's see how to set up our combat system on Crunch. To do this, first I'm going to create a montage here for each of Crunch's attack, including the air attack. I'm going to right click to select everything, right click, then use the edit, the create montage, create Anim montage. Then I'm going to select all the montages. I'm going to go to asset actions and edit selection in property matrix. I'm going to unfold blend option, blend in and blend out. I'm going to set the blend in to 0 and the blend out to 0.2 so that the attacks feel snappy. Next, I'm going to open my montage and I'm going to add the active frames and combo input window notify states to each attack animation montage. So here I'm going to do this for the first animation, and then I'm going to continue on with this section. So here I'm going to right click somewhere in the graph. I'm going to select add notify state. I'm going to check the combo input window. I'm going to make it so the combo input window happens, let's say here, for example, at frame 9. From frame 9 to frame, let's say 14, okay? I'm going to right click, select notify frame, set it to 9, and then I'm going to select Anim notify state frame and set it to, let's say, something like 5 frames. So the combo input window will be set between frame 9 and frame 14. Then I'm going to go here, I'm going to right click, select add notify state, and this time I'm going to select the active frames to deal damage. Here I'm going to begin the active frame, I think here, for frame 4 to frame 7. Select right click, frame 4, then right click again and end at frame 7, so a 3 frame active frames window. So first tip, don't forget to set the parameters of the active frames notify. I'm going to select this, and here I'm going to set the attack profile parameters. Damage amount I want it to set to 20, for example. And here in my case, the Crunch character, I want its left hand to deal damage. So like I said earlier in this tutorial, here I'm going to set the start socket to hand L for the left hand, and the end socket I'm going to set it to hand L2 so that the left hand of the character will deal the damage. Second tip, don't add a combo input window to the last attack if you don't want your combo to circle back to the first attack, okay? So if I get the last attack of my combo here, if I add a combo window, then I will be able to chain attacks indefinitely, because when it reaches the last attack, it will circle back to the first one. And third tip, like me, the character is punching or kicking, and like I just said, you can set the start and end socket to the same bone if you like. So now I'm going to create all the other montages, and I'm going to see you in the next section. Okay, so now that the animation montages have been created, I can go to my BP Crunch. Here, Combat System, add characters, and open my BP Crunch. And add the combat system component to it by selecting here add component, typing combat, and then I'm going to compile. And here on the right side in the details panel, I'm going to check system parameters. And here, instead of setting the animations to the Wukong's one, I'm going to delete everything here. Going to delete the air attack. And then I'm going to populate it with my Crunch's attacks. So Crunch has, I think, 4 attacks. 1, 2, 3, 4. I'm going to set it to Crunch attack 1, Crunch attack 2, Crunch attack 3, Crunch attack 4, and then Crunch attack air montage. So next, I'm going to add the IA attack input here. To right click IA attack and select the enhanced action event, so that whenever I left click, I will trigger the attack. I'm going to get the combat system, then call trigger attack on it. I'm going to connect this to the started pin of the input action IA attack. Then I'm going to press compile. And finally, last but not least, I'm going to open the ABP Crunch, the animation blueprint of my character, ABP Crunch. I'm going to go to the Anim graph. And here, I'm going to right click, select linked Anim graph, and then in the details panel, I'm going to select the ABP combat module. And here, instead of exposing as a pin the accelerating and in air, I'm going to show you something. You can select this and directly set to a variable of your blueprint. So here, in my case, the accelerating, I'm going to set to the accelerating parameter of my blueprint, and the in air, I'm going to set it to the in air parameter of my blueprint. So now I'm going to connect the local cache to the combat module and the combat module to the output pose. Then if I compile, save, and launch the game, you can see that Crunch can chain attacks after 5 simple steps. And now that Crunch is set up, I'm going to show you how to set up Steel so that he can receive damage. To do this, first I'm going to create a montage here for each of his hit attack. Hit back, front, left, right. I'm going to right click on them, select create, then create Anim montage. I'm going to select them all, right click again on the montages, go to asset actions and edit selection in property matrix. Here, you know the gist. I'm going to unfold the blend option, blend in and blend out, set blend in time to 0 and blend out time to 0.2. I'm going to save, close the matrix editor, and then I'm going to open the BP Steel. I'm going to open the full blueprint editor. So now you see that it has nothing implemented. I'm going to add a health system. And then I'm going to add in the health system all the hit reactions montage here. I'm going to click 4 times, 1, 2, 3, 4. 4. I'm going to select left, right, front, and back. And I'm going to select the corresponding montages. So here, A still hit left, A still hit right, A still hit front, and A still hit back. Here I can set the max health point to something else if I want to. I'm going to set the health bar offset Z to something like maybe 50. So it's up above the character. And then I'm going to open the animation blueprint, ABP Steel. And I'm just going to add here between the idle and the output pose, I'm just going to add a slot node. set to default slot so that we can play our montages. Now I'm going to compile, save, and if I launch the game, you can see that it works like a charm and that it just took us a few minutes to set systems on totally new characters. So congratulations to you, you've just created a complete combat system from scratch in at least a 60 minutes of tutorial. So here, of course, the system is not perfect and we can still add a lot of new functionalities such as applying a small dash on attack, tackling root motion and much more. But to be totally honest with you, I was not courageous enough to record a 10-hour tutorial. Maybe next time. So if I have time, maybe I'll update this system and set it on Gumroad for those of you who don't want to listen to my thick French accent for hours and hours. But for now, I hope that you found this tutorial useful and that you were able to learn at least one cool new thing about Unreal Engine. So if you want to learn more about Unreal Engine, you can click on this video and I'll see you on the other side. Advanced Hitbox, Directional Hit, and learn how to use simple specific moment in an animation. I'm so tired, I'm going to eat and sleep and play video games.